Hello, everyone. For the people that attended the session last week, welcome back. And for the newcomers, welcome to the Cleantech Learning Series. We hope you are safe at home and coping with the situation. As you all know, we are facing major issues in the cleantech sector and we need to start acting upon it. We need to create a supportive community of experts, partners, NGOs, public and private sector to help and support startups and entrepreneurs working in the cleantech sector to help them answer local, regional, and international needs in the sector. The Cleantech Learning Series are organized by Veritech under the Cleanergy program and funded by the Embassy of the Kingdom of the Netherlands in Lebanon. I will briefly introduce the Cleanergy Accelerator before welcoming our guests. The Accelerator aims at supporting ideas and startups working on solutions to the challenges existing in the cleantech sector. So we're talking about agriculture, transportation, energy, water, waste. Through this program, Veritech will offer the selected startups the resources, knowledge, support, and funding up to $37,000 in grants necessary for them to grow and scale. You can check additional information on veritech.org. You go in the program section, Cleanergy, and you can check whether you can apply and so on. So the deadline to apply is in the beginning of June. So I urge you to go and check the website and submit your application. Now, let's start with the Clean Technology Learning Series. It will happen every Tuesday in April on Zoom, having every week different guest speakers and entrepreneurs discussing the challenges faced in the cleantech sector, specifically waste management, water and wastewater management, and energy. At the end of the session, we will open door for a Q&A session for both guests and entrepreneurs. So this will happen on Slido. We will share now with you the website as well as the code for you to be able to write down all your questions so that the guests can answer your questions. So I'll not talk more. I would like to thank and to welcome our guest speakers in this webinar. We will be hosting Dominique Salameh, Khoder Eid, Hussam Hawwa, Jules Hatem, Jessica Abed, and Jaya Disciples. So in the first session on waste management, we have two guest speakers. The first one is Dr. Dominique Salameh, and we'll have also an entrepreneur, Khoder Eid. So we will start first with our expert in waste management, Dr. Dominique Salameh, who is the head of continuous learning and training department and doctoral programs at the Faculty of Science at USG. He is also the co-founder of the association Arc-en-Ciel.France. He has an intensive experience in strategy and waste management systems. Dominique will be talking about satisfying industrial value chain gaps through entrepreneurship and niche sector strategies, so the opportunities and challenges. Dominique, thank you for answering our invitation. We are glad to have you with us. I will leave you now to present your presentation.
Thank you very much, Joey. I just need to see if my screen is well shared. If you can confirm that. It's okay. You have.
Yes, we can see it.
You can see it properly?
Yes.
All right. I'm starting the slideshow. So first of all, I would like to thank Cleantech Management for inviting me to discuss such an important topic together today. I would like as well to thank St. Joseph University and the Association of Lebanese Industrialists with whom I discussed a lot this topic these later days. I will try to be as brief as possible in my opening presentation, just highlighting some principles to be exposed together, some examples, so that we have a better chance to discuss together these later on through our time together. Practically, I will not repeat what 2 years ago until now, still a reality. We are serious and very challenging crisis. What we are living today is not just a small thing, it's a big thing, but it is a part of the iceberg. Industry is struggling to survive in Lebanon. Industry is trying to convince the world of its crucial importance today and since many decades. Lebanese economy since several years was based on supporting imports, and really very limited strategies came to support within our border production. We are not here to discuss the reasons behind that. We will try to expose and to discuss solutions. But in fact, let us highlight that the problem was not just a Lebanese problem. It was an international mindset. World produced in China. Really, world produced in China. Now, game has changed, especially for us, especially in Lebanon, after the economic crisis. Really, we produce or we die. In the same time, waste management still is a very serious challenge as well in our country. Although the many attempts to plan and execute many solutions for waste, these solutions still are underestimating waste industrialization potential. It is true in fine that waste is a material. At the end, it is a material, and materials can be raw. You understand here properly, dear friends, where are we heading in our discussion today? We will think together how entrepreneurship in solid waste management can support industrial value chain. Value chain, such a big word full of strategy. Yes, unfortunately, industry in Lebanon knows value chain deficiencies within the same industry and inter-industries. Again, I will not read all of these here, but I will focus on one real important one, which is access to raw material. Access to raw material for a precise process, such as chemicals. I will go into a lot of examples, or support through annexed materials such as pesticides. You know, today, it's very easy to give lectures that Lebanon should produce more in agriculture. Still, will we be able to produce without pesticides, without biopesticides, without compost? Today, under this crisis, are we still be able to import all these? So again, in a classical way of definition, you may, and it's true to have in mind, that value chain is like the model of Porter's value chain, the Porter's value chain in picture, or some organizational schemes. This is true, because even this is lacking here in Lebanon. Nevertheless, we will focus today on waste, solid waste, liquid waste, leachates, and its potential to fill gaps in industrial value chain. In fact, as defined by the World Council for Sustainable Development, as well as the full product lifecycle analysis, as you may see in the picture on the slide, waste is at the heart of the value chain deviation. We can really see the terminology disposal and recycling, consumption/recycling, really within the value chain logic, the industrial value chain logic. In reality, and contrarily to the common definition that waste is a no more needed object, today we know, all of us, that waste is a subjective perception, as well as more process classification. Waste is
Dominique, sorry عم بس ما عم بسمعك.
Proper definition, an object that is
Dominique.
no more needed in actual context, not in general, just for me, and now I do not need it. Let us go into some examples.
Dominique.
Practically, let us consider that process. هلا عم تسمعوا أحسن؟
إيه عم بيقطش.
وين وقف؟ وين قطش؟
إيه آخر دقيقة ما قدرنا نسمعها.
وين ما سمعتوا بأي سلايد؟
هيدا اللي عليه بس صار له شي 30 seconds عم بيروح الصوت الانترنت.
جوي سمعيني شيء؟
إيه.
Now
Can you please,
سمعيني؟
إذا بدك, yes, if you want you can turn off your camera and just share your screen.
Will be. Okay. So I will go back one slide before.
But you need to share your screen, please.
I did it just now. Second. Talk. Shared?
Yes, perfect.
Okay. That slide you heard the discussion about it?
Yes.
Okay. So I was saying just quickly that waste is an object that is no more needed in its actual context to me. So let us take some examples. If I am the person considered process A, I use a jacket. I get warm for a period of time in my life, and I do not consider anymore my jacket useful. I will put it in garbage. It is for me a waste. Still, the jacket is a material that after processing, and here I highlight the terminology after processing, I will explain it later on, is really useful for another user or for textile industry. Many examples in international benchmark or national benchmark can be cited here, but I will just mention the Desigual model. Same logic can be described for car repair garage. The unusefulness oil waste after reprocessing can be again a useful raw material to be again waste or to be some raw material for burners. So the question is not the logic behind everything that I'm saying here. If you noticed, I always mentioned after processing. This means we always must have a revaluation process to make a waste useful. Financially, is it worth it? That question drove international economy for long decades. Countries prefer to produce what is lower cost and where is lower cost. To produce it where is lower cost. Resources were abundant in time, and in-house production was not always a strategy. At least in Lebanon. Lebanon was in that economy model. Today, the question of net value is more challenging. Constraints and much more, and are much more. Waste is now much more. Still, resources and access to resources are much less, and industry is facing real death. The salvation cannot come from ancient economical models. Today, circular economy interlinks between industries. Waste incorporation in value chain is the solution. And here comes entrepreneurship. When everything becomes heavy to change, entrepreneurship brings the freedom of innovation as a game changer. It brings focus on a solution, a unique one, a niche strategy. It is true what Stevenson said, entrepreneurship is the pursuit of opportunity beyond resources controlled. As well, it keeps us meditative what the big John Nash in person said, niche strategy is to focus on one thing, on one core business, precise and small enough not to attract competition. I can cite many examples. Still, give me here the opportunity and the luxury to highlight one Lebanese success story about a niche strategy, which is Arc-en-Ciel NGO success story in infectious waste management. It is one focused niche enterprise in its role of collecting and treating. Joy, are you hearing me?
Dominique, the last 15 seconds, no. So in collecting, we started talking about Arc-en-Ciel and then it got.
Yes, بعد عندكم share السكرين.
بعده, yes.
Okay. So I was saying that I was mentioning one example of entrepreneurship, in niche entrepreneurship, what was the infectious waste management network of Arc-en-Ciel.
Dominique? Dominique? Dominique, are you still in?
I am in. I'm terribly sorry. ما بعرف شو عم بيصير بالconnection عندي. Can I repeat?
Yes, definitely. بس maybe ما بعرف إذا أنت على 3G أم على الواي فاي.
أنا على 3G لأنه انقطع عندي الواي فاي بالمرة. So رح أرجع أعمل شير سكرين. ما بعرف شو عم بيصير عندنا اليوم. فوالا. عملت شير سكرين رجعت.
Yes, it's still loading.
All right.
Okay, yes, we can see it now.
Okay. سامعيني منيح؟
Yes.
All right. So I was saying that entrepreneurship in waste management should be a mitigation strategy for industrial deficiencies in value chain. Because industry is about value creation, is about standards, is about lean and resource efficiency. It's about focus and conversion into one process. And the feasibility studies should lead us such into answers like, should I recycle or upcycle? And it's the market who will prime to answer on such question. Now, everything should be designed under what is called blue ocean strategies, not ancient classical strategies, to reach the entrepreneurship in solid waste management. The importance of knowing our baseline. What is being done with our waste? What are our waste? What is the composition of our waste? What are the industry's need for our waste? What is the production of our waste? What are the plans in the countries for our waste? Blue Ocean strategy is to know exactly what everyone else in the ecosystem is competing on and to do something else. Highest in value, lowest in cost, crucial in the value chain. Let me give you some examples. If everyone wants to produce compost, go and create a lab for soil analysis. If everyone wants to burn waste, go and create local made filters. If everyone wants to recycle plastics, create link between producers and recyclers. Industry is about planning. Enhancing the waste value is really challenging. Here I am listing a list of criteria which are prerequisites to such innovation, such as innovation under market need perspective, a market conquest under product potential, circular economy strategy under policies constraints, and so on. I will just focus on one example or several mindset. Do not go and think that olive oil is not worth investing in. Why? Because in actual crisis, we will not be able to sell it. Think instead, what can I use the oil produced else than eating? Do not think it is not worth investing in potatoes. Think, what is the price of imported ethanol actually produced from potatoes? Do not say, what about ethanol burners? Besides, design and produce some locally made burners. Not think policies are against me. Think, what are policies gaps and how can I fill that gap? Don't just dream, build on entrepreneurship and think industry. Finally, dear friends, let us recapitulate the golden triangle linking entrepreneurship to industrial value chain. Entrepreneurship in waste should be done keeping in mind industrial value chain. How can we enhance overall national productivity, industrial productivity? How can we transform our waste management to be under industrial streams, to be industrialized? The golden triangle is an equilibrium of managing proper technological aspects implementation towards sustainable development. Any innovation should answer a demand to ensure the economy of scale. If not, it is worthless. Know your baseline. What is lacking? What will be lacking in the near future? And after all, have the courage to downsize your market to your country boundaries. This needs courage. Your niche model can go beyond then after that. In conclusion, you understood it well. What I wanted to say was entrepreneurship in niche strategies is the linking lack between solid waste and industrial value chain deficiencies. And I thank you very, very much for your patience.
Thank you, Dominique. Thank you so much for this great intervention. I will share now my screen, okay? Just a small reminder, if anybody has any questions, please go on Slido. You can go on Slido and ask your questions. Dominique, can you please stop sharing your screen so that I can share mine?
I just stopped.
Yes, perfect.
And sorry for the internet troubleshoot.
So you can go on slido.com and the code is 47485. I'll share it with you now. Here we go. So if you have any questions, please feel free to do so. Okay, I'll go now and check the questions. Okay, so one question is, can we have the presentation?
Of course, gladly, of course.
Okay, and the second question is, hi Dominique, thank you for this great presentation. Do you think the current financial situation will boost waste management?
I am fully sure that the current financial situation will boost innovation in waste management. Now, the thing is that we really need to control and manage the cycle of innovation in waste management so that we turn it into industrial oriented innovation so that we really tackle the problem. But of course, now we are facing a critical situation in having access to raw material. And as I said, waste is material and it can be transformed into raw. So we really need to focus on what we have as waste production or produced waste already in Lebanon or produced stock already in Lebanon that will become waste. If I can just extend one moment here, my explanation, it's really important. In the very chemical engineering definition, waste is not the problem. Accumulation of waste is the problem. Let us consider that we have stock of waste, industrial waste, municipal waste, house level waste. We have a lot of stock of waste already in the country. And all of these can be considered as material, raw material, if we deal with it properly.
Okay, and Rabia added, especially with the difficulty on the imports and the need for the material.
Exact.
We have a, yes, go ahead.
No, I'm fully agreeing with Rabia. So because of the difficulty on imports, we really need to consider our waste as a raw material and containing a lot of potential.
Okay, we have two other questions. So what can be done on a local level that does not require central governmental decisions?
Just before Joy, there was a previous answer by Anonymous. The percentage of PET plastic is currently that is being collected in Lebanon. This is exactly what I said when I mentioned we really need to have a baseline study. What is a baseline study? A baseline study is a real and a very serious and a complete study about such numbers. Today, we have a lot of reports. Today, we have a lot of what we call secondary data information. We really need to have a full scope of baseline understanding of and comprehensive observation and knowledge of our waste. This is the only way we can answer such questions. And I can add much more questions in these. And this is why I'm not entering into numbers, because we really need to go into a baseline study. We can add a lot of questions on that question, with like, what is the percentage of PET imported, not only exported? We really need to know that as well, because this is the key to know what is the need of raw material needed by industry and how to transform that plastic, because we all are in favor of reducing the usage of plastic. But this will not come tomorrow. So at least let us think circular economy, to use in-house plastic now, to try as much as we can to use it under upcycling or recycling streams so that it can be useful in the needed market. So, and to tackle the second question about the central governmental decision, I already answered that as well in when I said, do not think policies are against me, think what are policies gap? How can I fill the gap? Practically, independently of any central decision, the niche strategy is one focused strategy from cradle to grave under a life cycle assessment to answer one need through one solution. So there's a lot of design thinking behind that, and that can be feasible. The answer can be that within the policies, there will always be room for doing things to support policies or to continue the value chain, the industrial value chain. So let me give you just one example. Consider today that all the Lebanese policies are going towards a serious usage of plastics in one stream of technical solution, whatever will be the technical solution. And consider that in the same time, we have a super huge demand in industry on that type of waste. It will be an economical offer and demand in the market. And here we know always that offer and demand prime in economical mitigations.
And the last question is, can you please elaborate on the Blue Ocean strategy with examples for Lebanon?
Of course. Blue Ocean strategy is trying not to compete on a stream of waste. Let me give you one example. And this is, again, the importance of knowing the baseline. What means knowing exactly what is happening and what will happen to our waste. Let us take one example. If we go today and we say in Lebanon we have a solution. I'm just giving one example. We have a solution for tires, and we just have one market for reprocessing tires and to reproduce one type of products by tires. And if today I want to enter the market, thinking competitiveness strategy, which is the ancient way of waste management mindset thinking, is to go and say, how can I take from that part of produced tires to produce such same product, which can be mattresses or anything else, to go on the same market. The Blue Ocean strategy is to go and to try thinking that we have an additional industrial lack, such as the import today of brakes for car repair. And to understand and to elaborate a comprehensive and full process for using not only tires, but waste from recycling industries for tires to produce the cover of the brakes that we are going to use in car repairs. This is one example. Another example is when we think that today we have a competitiveness, as an example, for green waste. Like as using the apples to produce ethanol, and in the same time to use apple waste for any other streams, or use apples for streams as producing chips or else. Now, if we go and think Blue Ocean strategy is to go and to enhance on a policy level and to do a lot of lobbying on a policy level to enhance the productivity of apples in Lebanon, so that we go on a higher productivity of ethanol post-fermentation, or we can go on a higher productivity of burners of ethanol, so that we can really tackle the Lebanese need and the Lebanese market. These are examples of Blue Ocean strategies.
Thank you, Dominique. Thank you so much. And I think there is something very interesting that you said, which is actually searching the gap and looking at the gaps so that actually we can turn them into opportunities. And I think this is where innovation comes in.
Thank you. And I just want to highlight one more thing, the crucial importance of feasibility studies and financial. The difference between us and dreamers is that entrepreneurs transforms any dreams into a feasible action. And this is very important. Here comes the importance of feasibility studies for each Blue Ocean strategy and niche strategies in entrepreneurship. And I thank you very, very much for everything you said, Joe.
Thank you, Dominique. So now I would like to welcome Khoder Eid as the guest entrepreneur in this section. So following his studies in management of sustainable innovation and finance, Khoder found himself pursuing a dream of a green enterprise capable of promoting sorting at source while building social cohesion in unprivileged area of Tripoli. So Khoder will share his journey and will focus mainly on sorting at source as a duty and the right that should be affordable to all. Thank you, Khoder, for joining us. I will leave you now to lead on your presentation. So if you want, you can share your screen now. Yes, we can see you and hear you.
Okay.
Just a small reminder, if anyone wants to ask any question, please go on Slido and share your questions. We will answer them shortly. Okay. We can see your screen now.
Okay, hello all. Good afternoon. Merci Dominique على الانفورميشن اللي اعطيتها، واكيد مثل ما كنت عم تحكي انه عندنا bad waste management system. لما عم نحكي كلين تك او كلين تكنولوجي، نحن بنكون قصدنا حيلا بروسيس او برودكت او سيرفيس بيخفف لنا من الانفايرمنتال امباكت، but in the same time بيكون عندنا الانرجي باقل انرجي معقوله تكون. لما عم نحكي ويست مانجمنت رح نطلع على الانرجي او على التكنولوجي وين فينا نستعملها. بدنا نروح على يا معمل ريسايكلينج، هونيك رح نكون عم نلاقي مكانات ماشين، او انسينيريتورز. بس هي بالحقيقه مش هيك، لان بلبنان متعودين على موضوع الكولكشن دامبينج او ريسورتينج فاسيليتي، او اللي بيطلع 3% or 5 or maximum 10-12% من الكوانتيتي of the waste، او هلا عم نحكي بالانسينيريتورز. بس المشكله منها هون الويست مانجمنت هي لازم بالاساس تكون مقسومه قبل مرحله الكولكشن وقبل مرحله الريسورتينج لموضوع كثير مهم، هو الاويرنس اباوت سورتينج ات سورس. لان اذا ما عندنا سورتينج ات السورس المشكله رح تضلها والبروبلم رح تضلها موجوده. مثلا بطرابلس في جبل النفايات اللي هو مفروض يكون 12 متر، هلا وصل ل 32 متر وعم يبنوا جبل ثاني حده، مع انه في معمل نفايات وفي كولكشن مضبوط عم بتصير، بس معمل نفايات بس عم يقدر يفرز او يوصل ل 3%. ليش؟ لان نحن لما نجيب كل النفايات مع بعضها مخلوطه، اي تكنولوجي بدها تنعمل رح نحط عليها كثير انرجي تنقدر نعمل ريسورتينج فيز. هون جرين تراك اتدخلت وقلت انه وين البروبلم الاساسيه هي بالكالتشر. الليبانيز كوميونتي ما عندها او الكالتشر اباوت سورتينج ات سورس هي قليله. طلعت انه الكالتشر ما رح تكون موجوده مضبوطه غير لما نوعي مضبوط الكوميونتي، وطلعت على فئه معينه على نيش معينه من الكوميونتي، ولقيت اللي هن ستات البيوت، ماي مام يور مام، هن اللي عم يهتموا بعمليه ضب النفايات وتوزيعها باغلبيه البيوت اللي هي 70-60% من عدد البيوت بلبنان. فجرين تراك قسمناها اشتغلنا على 2 ميشن. اول نقطه هي to educate in Lebanon about sorting at source, and after that we collect and sort waste. For an example اعتمدنا على ثلاث مراحل. اول مرحله بنمشي فيها هو to raise awareness about sorting at source. After that we collect and sort, and after we sell. So 3 steps. For an example الاويرنس كامبين كمان ما لازم تكون بعيده عن الكولكشن فيز، لان اي غلط بعمليه الويست مانجمنت هي رح تودي لغلط او لنوت افشنسي بعمليه الريسورتينج فيز اللي هي ثالث مرحله. مثلا الفلاير اللي نحن اعتمدناها باول مرحله هو to separate the waste into recyclables and organic waste. كان في blue وبلاك bag. So under the building لازم الناس كمان تشوف blue وبلاك bins. تصدق الناس انه نحن ما عملنا سورتنج بالبيت ونزلنا حطيناها ببن ورجع اجى الكاميون حملهم كلهم مع بعضهم واخذهم على المعمل بطريقه يعني ما استفدنا شيء بعمليه سورتنج. سو لما الناس تشوف انه فعلا في سيستم راكب مضبوط تكسب الثقه تضل ماشي بعمليه السورتنج ات ذا سورس. وكمان الكولكشن لازم تكون مضبوطه. ما لازم الكاميون يجي يحمل الاورجانيك ويست مع الريسايكلبلز بعد ما الناس تكون عملت عمليه السورتنج از السورس. واخر شيء لما بنكون اول بارت عاملين سورتنج ات سورس مضبوط اللي هو الافضل شيء بالنسبه لنا هو تنقدر نوصل ل 3 بن اللي هو اول ريد بن اللي بقلبه كل شيء ريسايكبل، الاورجانيك بن اللي هو لونه جرين، والجراي بن اللي هو بقلبه كل شيء ريفيوزد ويست. لما بنكون عم نوزع هيدي الويست او النفايات لهالثلاث انواع بتوصل على المعمل او على الوير هاوس الموجود عندنا الاورجانيك ويست نظيفه، نقدر نستفيد منها بعدين بعمليه الكومبوستينج او حتى الريسايكلبلز مثل ما عم نشوفهم بالصوره رح تكون نظيفه. يعني قيمتها لما بتكون نظيفه يعني قيمتها عاليه، يعني نحن فينا نستفيد منها. يعني المعمل لما ياخذ هالقنينه البي اي تي ما بده يحط كثير انرجي عليها تيقدر ينظفها تبعدين يستعملها. Another example عن how we can educate in Lebanon about sorting at source. فينا نعمل مثل festivals أو عن كيف نعلم أهم شيء الفئة العمرية الصغيرة، لأن هي اللي رح تأثر على النيو جنريشن بالمستقبل، لأن هي مثل شان مترابطة بدها وقت تنقدر نغير هيدي الكالتشر الموجودة عند الناس عن السورتنج ات سورس. بدي احكي شوي مثلا هون كيف الفلاير عندنا احمر اخضر، البن لازم يكون احمر اخضر. هيدا الاكزامبل اللي عملناه اشتغلنا بشكا لمده 6 اشهر على عمليه سورتنج ات سورس، وهي صوره الاورجانيك ويست لحالهم والريسايكلبلز بيبقوا لحالهم. لما يكون عندنا سيستم مضبوط بيكون عندنا efficiency مضبوطه، بس تنقدر نحققها لازم يكون عندنا infrastructure مضبوطه. يعني الناس يكون عندها صحيح هو واجب يعني الناس انها تفرز من المصدر تبعدين نقدر نعمل كولكشن مضبوطه وعمليه ريسورتنج مضبوطه للويست، ونقدر نخفف قد ما فينا عن الدمبينج او الانسينيريشن. بس كمان هو حق، لأن بلبنان ما بعتقد أغلبية الناس عندها الريسورسز المضبوطين انها تو سورت ات سورس، فإذا لازم نأمن لها هول الريسورسز. فور ان اكزامبل كان المستوعب المضبوط، اللون المضبوط الموجود تحت البيت، او يشوفوا الناس لما عملنا كولكشن عملنا ما رجعنا خلطناهم مع بعض. وبالاخير بالعمليه الريسورتنج نقدر نستفيد اكثر ما فينا من هيدي المواد اللي هي المعامل اللبنانيه بالفعل بعازه كثير لها، وهيك بنكون عم نخفف الامبورتيشن بالنسبه للرو ماتيريال ان كان البلاستيك والورق والكرتون. وكمان اذا كل شيء مثل بلبنان عم بيتم تصديره كمان نقدر نستفيد منه وبتعلى عمليه الاكسبورتيشن بهيدي الماتيريال بهيدي الرو ماتيريال. Thank you. Any question?
Yes, thank you, Khoder. I will share now my screen so that you can read the questions. Voilà, يلا. Okay, so we have many questions. رح نبلش بأول وحدة. The solution is clear and the ways are even clearer, but no one is doing this fully. What's the problem?
Yes. البروبلم انه رح خبركم شوي عن السوليوشنز الموجودين بلبنان اللي for an example Arc-en-Ciel one of them. في زياد أبي شاكر اللي كان الأسبوع الماضي عم يشتغل على الموضوع. في ليفلوف ريسايكل بتستعملوا الاب تطلبوا بيجوا بياخذوا الكيس مفروز من البيت. في مثلا هول ريسايكل بيروت كمان عم يشتغلوا على to find a solution للسورتنج at source. بس كل حدا منهم وانا one of them عندنا البزنس بلان اللي مختلف عن الثاني. For an example إذا رحنا على solution اللي عم يطرحه ريسايكل بيروت عم بيقول نحن تنقدر to be sustainable لازم ندفع الشخص أو اليوزر for an example ما بعرف الرقم بالتحديد 10,000 ليرة على الكولكشن. طيب شو بالنسبة للأشخاص اللي ما بتقدر تدفع ال 10,000 ليرة بالشهر؟ For an example live love recycle نحن بنعرف إنه الآب أغلبية اللي بيستعملوها هو الأعمارنا يعني النيو جنريشن أو الأشخاص الفئة العمرية الصغيرة مش الكبير بالعمر. يمكن ما يكون لهم جلادة ينزلوا الآب ويطلبونا أو يفوت بهذا البروسيس. كل مين عم يعطي سوليوشن لفئة معينة من الأشخاص. المطلوب هو الكولابوريشن بين هال-entrepreneurs أو هال-solution to find the better أو the better solution. ما بعرف إذا قدرت جاوبت على السؤال المضبوط.
بلا وكان في سؤال كمان عم بيحكي كمان إنه قد إيه it's important mainly هال collaboration between startups and other companies for you to sort.
لازم تكون.
إيه. في سؤالين رح أجمعهم بواحد. Why don't you buy the recyclables؟ وتاني واحدة هو how difficult was it for you to find buyers for the metal, plastic, textiles waste that you collected? Is this getting easier with time? So هون عم نحكي كيف عم بتجيب الويست.
أوكي.
كيف عم بتبيع الويست؟
يلا. To buy the recyclables. إذا I don't have any income أو resource to fund هيدا الأوبريشن. أوكي إذا المونيسيباليتي أوكي عندها عقد ديجا موجود مع for an example بطرابلس لافاجات وفي عقد تاني مع AMB اللي هي بتهتم بعملية ريسايكلينج. أوكي طيب إذا المونيسيباليتي أو اليوزر ما دفعوا لي أنا أقدر أعمل الأويرنس كامبين أو أقدر يطلع عندي ريسايكبل. أوكي كيف أنا فيني غطي عملية الأوبريشن؟ فإذا بدي أشتري ريسايكبل من الأشخاص أو أدفع حق هيدا الريسايكبل بلا ما يكون عندي source of income تاني يقدر يغطي هيدي العملية it will not be a sustainable solution. فينا نعملها بطريقة واحدة إذا اشترينا بالمفرق for an example من الأشخاص هول بيسموه لي ساكاجور اللي بتشوفوهم معهم عربيات هيك موتور صغير بيمرق مثلا بتاخذوا الطن أو الكيلو ب $100 for an example بترجعوا بتبيعوه ب $120. بس كمان هيدا الشيء ما بيصير لأن في عنا مونوبول بعملية الشراء هيدي الماتيريال بلبنان. يعني السعر تقريبا بده يكون موحد للمعامل الكبيرة. طن البلاستيك PET for an example بال $150 أو بيوصل أيام لل $200 أو بيرجع بينزل لل 120. ما بنقدر إذا بدنا نبيعه للمعمل واصل لعنده ب $120 لازم نكون عم نشتريه بأقل من هيك بكتير تنقدر نغطي عملية تكلفة الأوبريشن. لهيك ما بنقدر نشتري الريسايكل.
Okay. Do you wash the contaminated bottles?
هو الكونتامينيتد بوتل نحن مفروض من عملية الاويرنس نكون لما الشخص اللي طالع على الهاوس هولد الومن لما تدق الباب واليوزر يفتح او الكلاينت او البنفشري يفتح الباب وتعطي عمليه التوعيه او الاويرنس كيف بتصير او هاو تو سورت بالبيت، نحن بنكون ديجا عم نطلب من هيدا الشخص انه يغسل او ينظف الويست تبعه او كل شيء ريسايكل موجودين. هيدي جزء بدها تكون من عمليه الاويرنس نحن بيوصل عنا، او اذا الواش بيصير بالمعمل النهائي او الشخص اللي بيشتري القنينه عنده اذا ما كانوا منظفين.
Okay. في حدا سائل I would like to know what is the percentage increase in sorting they contributed to with their NGO, meaning what is their impact so far?
نحن صار لنا تقريبا 3 سنين عم نشتغل as idea وسنة مسجلين رسميا بلبنان. خلال هول 3 سنين نحن وصلنا تقلنا نعمل awareness لحوالي 22,500 بيت. عم نحكي نورس على ب8 مناطق. اتحاد بلديات المنيا كان على 5 بلديات بشكا وبطرابلس. هيدا الامباكت اذا عم نقيس على صعيد هاو ماني هاوس هولد قدرنا نوصل وندق الباب ونعمل عمليه الاويرنس، وهيدا كله بعدين بيصير كل هاوس هولد بعدين بيصير الامباكت تبعه بيتقسم على الكوانتيتي اوف ويست جنريتد.
اوكي، بعد عنا سؤالين. Hello, thank you. First, did you do a neighborhood pilot or all village at the same time? والتاني شيء cost of the awareness campaign. أكيد it's up to you whether you want to answer or not.
Yes. Yes, for sure. أول شيء بلشنا as a neighborhood pilot وما قدرنا نعرف الريزلت غير ما عملنا هيدا البايلوت بروجكت على ال 5000 household. وأنا قبل ما يعني لما عملنا الأويرنس كامبين وزعنا باج مع الفلاير، أنا ما كنت عارف أو ما كنت بتخيل إنه رح تكون الريزلت هالقد حلوة وهالقد رح أقدر كفي يعني بعد 3 سنين من الأيديا جاست هيدا البايلوت بروجكت اللي صار. لأن بسبب الريزلت اللي أخذناها من الأويرنس كامبين قدرنا نتوسع او نوصل الايديا بطريقتنا بعمليه الاويرنس كامبين لبقيه بلديات او مناطق بلبنان.
اوكي، في سؤال بفتكر هلا in this time it's very important to ask this question. Mainly it's how are you protecting the people that are working now in waste, especially due to the coronavirus. I think هيدي question كمان is part of the challenges that you're facing when launching your startup and so on. So إذا بدك هيك to
Yes, for sure. نحن أول أسبوع كنا عم نفكر كيف نقدر نكفي. جبنا الماتيريال اللي الحماية البروتكشن، نعقم الريسايكل اللي عم يطلعوا، بس لقينا بالنسبة لنا it's very very costly. وعن جد كان التشالنج الكتير كبير خلال هول الأسبوعين 3 اللي قطعوا. نحن اللي عملناه إنه طلبنا من الناس، مرقنا على النيبرهود، قلنا لهم انه بليز ستوب هلا هيدي الفتره بس هالاسبوعين، ورجعنا عملنا الكولكشن للبنز اللي كنا موزعينها على انه نرجع بعدين نرجع نوزعهم بعد ما تخلص
الفيروس.
المرحله. هوبفلي انه نقدر نتخطى هيدي المرحله كلياتنا. yes it's big challenge.
اوكي.
منا we are not مثل نقدر نعمل كنترول كتير قوي على العمليه، لأن بدها كتير كنترول وما كنا مستعدين لها، وهيدا شيء لازم بعدين بالمستقبل اكيد بس لما نرجع نبلش نكون حاطين بلان تنقدر بحال واجهنا مشكله بعدين او كرايس بعدين نقدر نكون عندنا جاهز السوليوشن لها.
Okay, we still have 3 questions. رح اقول لك اياهم كلهم لانه بعد عنا 3 دقائق before we start the next session. So اول وحده, did you cooperate with the Trablus تفرز؟ وثاني شيء, don't you think having a law forcing the source waste sorting is needed? واخر سؤال هو, when making compost, how are the microbial issues that usually come with animal product dealt with? You can read the questions on the screen.
Yes. بالنسبة لطرابلس تفرز أو الفيحاء تفرز، كنا بلشنا عملنا كذا 2 ميتينج وعم نجرب how we can collaborate together، لأن هن بلشوا بال 2018 تقريبا وعملوها شوي غير هني شوي سنتراليزي، يعني حطوا المستوعب الأحمر أو الأزرق بكل منطقة. نقوا بطرابلس مثلا افترضنا بمنطقة الضم والفرز كان عندنا مستوعب كبير للسورتنج ات سورس، اوكي. بالمينا كان عندنا مستوعب ثاني. طيب أنا اللي عم بعمله هو شوي غير إنه نوصل أقرب للناس، يعني under the building، غير ما إنه الشخص ياخد هيدا الكيس ويدور سيارته ويروح على المستوعب يمكن يكون بعيد عنه، وبالتالي كمان هيدا it's a new challenge بالsorting at source. نحن بدنا نجرب نسهل على الناس قد ما فينا تنقنع الناس بالsorting at source، ما نخنق ما نصعبها على الناس. So هيدا الشيء اللي بدنا نجرب نتعاون hopefully in the future بيناتنا تنوصل ل ideal solution بيناتنا. So yes لازم. بالنسبة للكومبوست I'm not expert بالكومبوست، بس كمان برجع بشدد على موضوع الكولابوريشن. أنا لما بيكون عندي بروجكت مفصول بين ريسورتينج اورجانيك ريفيوز، بحب روح اتعاون فور ان اكزامبل مع كومبوست بلدي اللي هن اكسبير بعمليه تحويل الاورجانيك ويست لكومبوست. سو مش انا اللي رح روح اتدخل بهيدي التكنيكال بارت. نحن عم نشتغل اكثر على المانجمنت اوف ذا بروسيس، not بالتكنيكال لكل فيز من الويست مانجمنت. Yes بالنسبة لللو we can't work without the law. يعني كتير صعب، هو it's the main challenge انه ولا ما بنقدر او ما بنقدر نقنع الاشخاص غير ما يكون عندنا لو عم بيرسم او عم بيحدد لنا على طبيعة العمل او الواجبات للناس للكاستمر او الكلاينت او نحن. بس لأن مش موجود أو بلش أو ما تكفى، بالتأكيد هيدا it's big challenge for us إنه نقدر نقنع الناس بالsorting at source. hopefully إنه كمان إن شاء الله مع الحكومات الجاية نكون اللو يتطور ويصير مفروض على الناس إنه تفرز أو تصوت.
Thank you Khoder. Thank you so much.
hopefully انه هيك جربت احكي لبناني كون قريب هيك بشكل سريع ما يكون معقد القصه ان شاء الله اكون فتكم كلكم. ميرسي كثير.
Definitely. So I would like to thank Dominique and Khoder for this great intervention. You talked about collaborating with the startups and so on. I think also this is very important. At the end of the day, we're not here to compete, but we're here to make the world a better place. So it's very important. So now we will take a few, we will start directly with the second session. Okay, so the first session focused mainly with Dominique Salameh and Khoder Eid. They shared their knowledge in the field of waste management. Now what we will do is we will start with the water and wastewater management session. So it's the second session. I will go through the presentation for the people that just jumped in the call. So I'll go back to present the Cleantech series before starting with the second session. Okay, so if anyone was already in the session, you can take a couple of minutes before we welcome our guest again. I would share now the video of the Cleanergy Accelerator. Here we go. So hello everyone. For the people that just joined, I will explain quickly about the Cleantech learning series. So as you all know, we are facing major issues in the cleantech sector, and we need to start acting upon it. So mainly we need to create a community of experts, partners, NGOs, public and private sectors to help and support these startups that are working on in the cleantech sector, specifically on challenges in transportation, energy, water, waste, and agriculture. So the Cleantech learning series are organized by Veritech under the Cleanergy program funded by the Embassy of the Kingdom of the Netherlands in Lebanon. So about the Cleanergy Accelerator in brief, the Accelerator aims at supporting ideas and startups that are working on solutions to the existing challenges in the cleantech sector. So mainly the teams will have to tackle challenges in transportation, energy, water, waste, or agriculture. Through the program, Veritech will offer the selected startups the resources, knowledge, support, and funding necessary to scale and grow. You can go on veritech.org, go on the program section, click on Cleanergy, and you can see additional information about the accelerator and how to apply. So the deadline for the first batch is in the beginning of June. So if you have an innovative solution in the cleantech sector, I urge you to go check the website and hopefully apply. So to go back to the Clean Technology Learning Series, it will happen every Tuesday in April on Zoom. We will have every week different guest speakers and entrepreneurs discussing challenges faced in the clean tech sector. In this case, we are focusing on waste management, water and wastewater management, and energy. And after each guest speaker or entrepreneur will have a small session of Q&A. So you can ask all your questions on slido.com. If you go on the discussion on Zoom, you will see the code. So just put in the code and you can ask all your questions. Of course, the guests will answer you. So I would like to thank our guest speakers and entrepreneurs in this webinar. So we already hosted Dominique Salameh and Khoder Eid. They were talking more about waste management. And then we still have 4 guests. So we still have Hussam Hawwa, Jules Hatem, Jessica Abed, and Jaya Disciples. Okay, so in the second session on water and wastewater management, we are welcoming 2 guests, Hussam Hawwa and Jules Hatem. First, we will start with our expert in water and wastewater management, Hussam Hawwa. Hussam is the founder and CEO of Difaf. Currently, he is part of the curator team and board member of Fast Forward 2030 Lebanon. He has over 12 years of experience in conducting, managing, and assessing projects in the water, wastewater, and environment sectors. Hussam will be talking about wastewater treatment and reuse potential in Lebanon, considering circular economy principles. Hussam, thank you for joining us today, and I will leave you now to lead on your presentation.
Thank you, I appreciate it. Hello everyone, so thank you for joining. I would like to just share my screen now to hope it works. So please, Joey, just tell me if it's not showing. And
not yet.
Yeah.
Okay, now it's working.
Yep. Okay, and thank you. I have a small video at some point. So, hello everyone. So the session will be about wastewater treatment, reuse potential, and the concepts of circular economy, focusing on Lebanon, of course, and industrial wastewater. Quickly about Difaf. Difaf, we're an environmental technical bureau that is concerned with environmental solution provision. And the aim is to protect and restore the water resources and the vital environment that we have for the prosperity of our communities and cultures. The sectors that we work in are water, wastewater, environment, and agroecology. And our services range from field assessments to project development to solution design and procurement, environmental audits, monitoring evaluation, and capacity building. So for most of the human history, everyone has lived sustainably and pretty much in harmony with nature. However, with industrialization and catalyzation to linear economy, this has changed us into a take, make, use, dispose culture, which is accentuated and led us to excessive consumerism of the planet's resources and the pollution of our ecosystems. This, of course, led to extreme weather conditions, which we see every day, and problems of rising sea levels, etc., drought, etc. So this calls for a transition from our current unsustainable linear economy to a more circular economy. And here I have a small video. I hope it's going to work well. Joey, again, if you can please help me if it's not.
Okay, but the sound is not working.
Oh. Okay. 1 second.
If you can stop sharing your screen and reshare it again.
Yeah. It's not working.
Okay, now you can share your screen.
Yeah. I'm gonna try to remember how we shared the video sound.
So when you share your screen, you need to take share sound.
Yes. Okay. Yeah.
So if you have any questions for Hussam, go on slido.com. The number is 47485. Okay, so I think Hussam pressed quit meeting. He will join us shortly. So just a small reminder, if you have any innovative solutions, go on Cleanergy, check the program. We are posting on weekly basis challenges in the clean tech sector. So take this opportunity since we are all home to maybe go through the challenges, check the common challenges that we are facing, not only on a local scale, but also regional and international, looking at the gaps and try to find a solution so that we can innovate and move forward and have a better world. So Dominique was shared this as well, and I think it's very important. So really sorry, we are checking with Hussam. He's joining us again. So of course, now we are all going back to the digital world. So we're trying to adapt as much as possible. So maybe we can start with Jules in the meantime. Jules, are you ready?
Yes, I am ready.
Would you mind if we start with you while
No, don't mind at all.
Okay, perfect. So first, thank you, Jules, for jumping in. Jules is the founder and managing director of EEE, Environmental Evolution Engineering. EEE offers innovative wastewater treatment solutions based on decentralized domestic sewage treatment plants aiming at micro, small, and medium facilities. Jules will focus on the decentralized innovative solutions for wastewater treatment in Lebanon. Thank you, Jules. Hussam, we are starting with Jules. Is it fine so that we can figure out how to fix the issue?
Sure.
Okay, Jules, you can start if you want.
Okay. Hello, everyone. I will do a small presentation about the decentralization of wastewater treatment, and especially about the solution offered by our firm, Triple E. Okay, I think I have 10 minutes only, so I will try to go quick because it's a big presentation, but I will try to go quick. Okay, as we all know that. Am I sharing my screen on Zoom?
Yes, you are. Yes.
Okay, lovely. Great. Okay, great. So as we know, the water is very essential in our life and critical. We use water to produce everything that we eat, everything in our life. For example, it takes 5,000 liters to produce 1 kilogram of rice. It takes 500 liters to produce 1 orange. It's a bit shocking, these informations. The water is the meaning of life. It enters in our organism in every component. The problem and the water, and the same time, the characteristic of the water, it's because it's a universal solvent. It can dissolve let's say, a very huge number of particles. This is a advantage and at the same time an inconvenient, because it can contain organic matters, inorganic matters, domestic sewage, industrial waste, microorganisms, etc. We have let's talk a little bit about numbers. For example, only 0.3% of our water that we can use in the world, it's usable for us, it's useful for us. And the consumption of water is growing in exponential phase. It's like the corona graph. You can see it every day on the news. So the water, it's a bit looking like the corona graph, the consumption of the water. To introduce a little bit of Triple E and our solution for the wastewater in Lebanon, let's talk a little bit about the sectors of usage of water. For example, the agriculture, the domestic, and the industrial use. As you can see here in this graph, the agriculture use of water in our life, and between the dark green and the light green, you can see the waste that we don't use, okay? And if we can see it in the domestic use, the difference is huge, okay? So we preferred in Triple E in our firm to concentrate on this part, the domestic use, okay? 58% of the water is used outdoor and 40% is used indoor, okay? Unluckily, we cannot control the outdoor usage on a personal level, but as for the indoor usage, we can interfere, and we can interfere with high efficiency. In the indoor usage, 30% is for the toilet flushing. So if you use, for example, 200 liters per person per day, we have more than 60 liters is only for the toilet flushing. For the clothes washers is 23%, and for the faucet is 14%. Okay. The problem in centralization and decentralization of reusing and management of this wastewater is very essential here in Lebanon, because there's a big dilemma. I will take my time on this slide, because there's a big dilemma in our market and in our state and our government if we go for centralized or decentralized solution. Theoretically, the centralized solutions for the waste water are more efficient in a powerful nation where there's a good government with high fund, with high liquidity, with decision making, with high decision making. But in a weak country like ours, and especially regarding the money and the decision making, it will cause a big problem. For example, let's say, for example, the wastewater treatment here in Lebanon. Okay, so theoretically, you will say that, okay, why the nation don't take decisions to build, for example, 10 huge centralized wastewater treatment plants that will cover all Lebanon. For example, the sewage treatment plant of Jeddah covers like 1 million cubic meters per day. Okay, it's 4 times the capacity of, or the quantity of the sewage thrown by Lebanese people. So we can easily do 10 or 5 mega wastewater treatment plants and solve all this problem. But unfortunately, this is not the case. That is not the case here in Lebanon. There's no decisions, there's no sufficient funds, and even if there is, it will take a lot of time. For example, the master plan, it's been from the 60s for the wastewater, and it has been updated in the 92 and 2001. Until now, we don't have more than 5 wastewater treatment plants working in Lebanon. I'm talking about centralized and big one. This is why EEE, Environmental Evolution Engineering, it was started like an idea, and then it moved on to be a sustainable business that offers a decentralized solutions. What's the meaning of decentralized solution for wastewater? It is the private sector will take the responsibility, the constructors, the entrepreneurs, the designers, the engineers, the civil ones, the architects, etc., and they will incorporate micro wastewater treatment plants in their design for the buildings, for the households, for even, let's go for a village with a municipality. So in this case, EEE offer an innovative solution, a friendly user solution, micro and small size wastewater treatment plant to solve this problem over the private sector, over, let's say, particular innovatives. Okay, as I said before, the centralized wastewater treatment plants need a lot of work, need a lot of money, and especially there's more than 50 to 60% of our villages in the country, they are not connected by sewers and by network. But they are counting on septic tanks where they threw the wastewater in a open bottom underground tanks, or I can't say tanks. It's dumping of the wastewater that will go to the underground water, to the rivers, to the landfills. So this is the problem. Okay. So EEE took into consideration the wastewater problem and looked into the different parameters, microbiological, physicochemicals, and aesthetical parameters for the wastewater through qualification of the volume, degradability, and chemical types, and quantification of the pollution, and offered a compact or small micro wastewater treatment plants. The innovation in this product that it's very flexible. It can be fixed or mobile. Fixed, it can be a concrete underground tank, okay, with incorporated incorporated machineries to treat the wastewater. I will explain a little bit about it. Or it can be mobile. It can be mobile, a steel structure tank, or even a plastic tank that can be a compact plug and play. So we can install it one day here in our village beside my house, and then move it to another house, and very flexible. It can be above the ground, and it can be exposed, and it can be underground also. and it have a capacity to treat 1 cubic meters per day. 1 cubic meter per day is equivalent of 1,000 liters. So the consumption of 5 ordinary people. So it's a family or a small household, and it can go to 50, 500, 750, and up to 1,000 cubic meters per day. So it can treat the water for a village, 5,000 people, but not more. So as I said before, I am focusing on the decentralized solutions that can be adapted by the private sector, and not and of course very huge treatment plants are not affordable by the private sector. It's the duty of the state, but waiting the state to take that duty and to take it, let's say, between brackets, serious, we have to solve our problem. And finally, in this product, about this product, it can use different technologies, and it can be adapted to the use of the holder of this plant. So regarding the technology used and the money that he wants to pay, he can have a technology that can convert the domestic wastewater of his house into irrigation water. Can use it for green areas. It can use it also for inside the house, but only for flushing. He can go up with the technology to use it at domestic, and even we can reach the potable water from wastewater. But of course, the cost of these plants as direct and operational cost for potable treatment plants is high. So mainly and basically in Lebanon, we are going for the irrigation and for the toilet flushing. It means treatment of black water to reuse it back into the green areas, or even to reuse it back as gray water that can go into toilet flushing. As I said before, the advantages of this plant is the price. It's at very affordable price for a small household, or even a building of 6 apartments, 8 apartments. Very affordable price. The technology used is very can be advanced and can be moderate. Based on the request of the customer. The maintenance is easy, and it can be done by ordinary people. It don't need technicians, don't need qualified engineers. The consumption of the energy is moderate. It's a patented technology, and it's very flexible. As I said before, it can be used for different purposes, and it can be installed above the ground, under the ground, can be concrete, steel structure, etc. I think I don't have much time, but I will go a bit fast on the technology used. So in the potable water and the domestic wastewater treated to become a potable water, we went into a membrane process called the membrane bioreactor, or a submerged membrane bioreactor. So it's a classic biological treatment based on bacteria and biodegradation, and it's combined at a final stage with a physical and membrane or mechanical treatment to go through a ultra membrane to have a very high quality outlet water to be used as potable water. The process is called membrane bioreactor. Of course, we can go through pre-treatment. It's a physical treatment to remove big particles than we can see in the water. Then we go to the biological treatment. It's a biodegradation done by bacteria and based on dissolved air into the biological treatment tank. Then we go into the membrane process, the mechanical process, to do a ultrafiltration and to have a very high quality of water. Okay. Then, if we don't want to use the water for drinking, we can go for irrigation water. So it will be a less sophisticated system, let's say, and less consumption of energy and direct cost, etc. It will be based only on a pre-treatment, a biological treatment to remove pollutants from water like BOD and COD, phosphate, nitrate, and then into a classic sedimentation sediment the sludge and reuse it once again, and to clarify the water to be aesthetically acceptable. Then a disinfection system to remove the microbiological components like bacteria and viruses from the wastewater. Then the water can be easily used for irrigation. Maybe I passed my time. I think so. So I will be, yes. I am now ready. I won't continue with the presentation. So I am ready to receive the question. Okay, Joy?
Yes. Thank you so much, Jules.
You are the most welcome.
So now I'm sharing with you the questions. Okay, we have 5 questions, so I'll start with the first one. What is the cost of such a solution for use up to 10 people and running cost for irrigation? And is it available as final product?
Yes, of course, it's available as final product. We've been providing these solutions for the country all over from 2012. So it's been 7 years that we provided hundreds of plants. What is the cost for 10 people? So it's 2 cubic meters per day. If you want to go to an ordinary treatment plant for irrigation for 10 people, and a compact one, plug and play, made of plastic tanks, it can go up to 3,700 US dollars. And the running cost of the plant, it's not more than $30 to $40 per month between the energy and the disposables that should be used, or the chemical like the chlorine.
We have another question regarding also the cost, which is about what about the maintenance cost? What spare part could we need to replace? Is it available in the market? And maybe if you can share implementation cost.
The implementation cost, as I said, we are we are entrepreneurs, but we are at the same time a corporate, so we are a business. So once I said that the cost of the plant is X, so the cost of the plans, the implementation, the commissioning, the tuning, and everything from A to Z. What spare parts should be replaced? Okay, there's no big disposable like filters or something like this in the plant, but we need, of course, energy, and we need chlorine for disinfection, okay, instead of using UV or high cost components. So it will be mainly the energy, and it will be the chlorine. The maintenance cost, as I said, it's and when I said the running cost, including the maintenance, so it can be done by ordinary people to check if the panel is working. There's no unordinary sound or etc. But at the end of the day, it's a mechanical system. It's an electromechanical system. So we cannot predict at 100%, and we cannot guarantee at 100% that we won't have a failure at a component. Maybe it will be a very small failure at the circuit breaker, for example, in the panel. So it's something basic and something that can be done by unskilled people in this field.
Okay, now we have a question. What about the collection and reuse of biogas like methane in the small scale of grid solutions you are proposing? Is it meaningful, doable?
I was going to say this. We thought about this thing, but the problem that at a small scale, it's not worthy. It's not worthy to pay for a big cost cogenerator, for example, or something to reuse the methane or this gas. So it won't be something feasible, or it won't pay back. For the biogas and the methane, it could be implemented at a big wastewater treatment plant like the one in Tripoli, as I saw in the first question.
Yes, so let's go to the first question. We have a centralized wastewater plant in Tripoli finished 7 or 8 years ago and not yet commissioned. Can you help us with insights? Why is that so?
This is what I said. This is the difference between centralized solution done by the state and the one done by the private sector, like companies like us. But we cannot interfere since we are a private sectors and we are not the big, between brackets, contractors that work with the state. So regarding EEE, we can take fastly decisions, we can be flexible, we can install treatment plants, even medium one at the villages, commission tuned and have a collaboration and coordination. But when it becomes to the CDR and the state and the ministry, etc., so to take a small decision, it will take years and years and years. This is why I said we cannot wait for centralized solution. We cannot wait to the state will decide to do, like for example here in Sur and in Tripoli. In Sur there's a finished treatment plant from 2013, and I visited. Till now there is no connection to a network with sewage. We are waiting for the sewage, and once the sewage will arrive and the network will arrive, we have to do huge maintenance and rehabilitation works for the Sur plant to working again, so we will be paying 2 times. And I think this is the case in Tripoli. Unfortunately, we cannot interfere for the reasons I mentioned before.
Okay, Jules, we still have a minute before we jump to the second presentation. So I think these 3 questions, we can have quick answers for them.
Yes,
so yes, go ahead.
Julie designs the micro water processing plants. Do you manufacture them in Lebanon? Have you looked into exporting this plant, including to Africa? Yes, of course, I manufacture them in Lebanon. They are 100% made in Lebanon, but of course the components are from the countries, but the installation and the manufacturing and the technology is 100% Lebanese. In terms of importing it, yes, I will be so much interested, especially for the compact treatment plants. It can be easily transported to another country. Maybe you can have my email or my, I don't know, here, you can email me for this thing. What is the lifetime of the product and how often does it need maintenance? The maintenance works are easy. It have to be checked every 1 week or maybe less. The lifetime, it won't be less than 20 years to 30 years, for, of course. How will you work with the municipality to implement this system? The work with the municipality is a bit easier than the state. A municipality can have a easy decision, especially if it owns a terrain and it has a fund and also a network. So it will take a decision in a few days, or maybe let's say 1 or 2 months, and to assign us to build a centralized, let's say, a medium wastewater treatment plant for the village. So it's something more flexible with the municipalities and with the state.
Okay, so
solution, what happened is on mountain or chalet. Okay, the first question, it's a bit big and it need to be elaborated. So if really someone needs more information about this, I don't know, Joey, if I can share the contact in the chat.
Definitely.
Here.
Yes.
Okay, I'll say it. So you can send me an email whenever they want, and I will be glad to answer the questions.
Okay, thank you so much, Jules.
Thanks, Joey.
And thank you for jumping in as well. Hussam, you're back with us, yes?
Hey, hi.
Yalla, welcome back. Do you want to share your screen?
Yalla, let's give it another shot. Okay. Share computer sound. Here we go. Yeah?
Yes.
Okay.
Living systems have been around for a few billion years and will be around for many more. In the living world, there's no landfill. Instead, materials flow. One species' waste is another's food, energy is provided by the sun, things grow, then die, and nutrients return return to the soil safely. And it works. Yet as humans, we've adopted a linear approach. We take, we make, and we dispose. A new phone comes out, so we ditch the old one. Our washing machine packs up, so we buy another. Each time we do this, we're eating into a finite supply of resources and often producing toxic waste. It simply can't work long term. So what can? If we accept that the living world's cyclical model works, can we change our way of thinking so that we too operate a circular economy? Let's start with the biological cycle. How can our waste build capital rather than reduce it? By rethinking and redesigning products and components and the packaging they come in, we can create safe and compostable materials that help grow more stuff. As they say in the movies, no resources have been lost in the making of this material. So what about the washing machines, mobile phones, fridges? We know they don't biodegrade. Here, we're talking about another sort of rethink, a way to cycle valuable metals, polymers, and alloys so they maintain their quality and continue to be useful beyond the shelf life of individual products. What if the goods of today became the resources of tomorrow? It makes commercial sense. Instead of the throw away and replace culture we've become used to, we'd adopt a return and renew one, where products and components are designed to be disassembled and regenerated. One solution may be to rethink the way we view ownership. What if we never actually owned our technologies? We simply licensed them from the manufacturers. Now, let's put these two cycles together. Imagine if we could design products to come back to their makers, their technical materials being reused and their biological parts increasing agricultural value. And imagine that these products are made and transported using renewable energy. Here we have a model that builds prosperity long term. And the good news is, there are already companies out there who are beginning to adopt this way of working. But the circular economy isn't about one manufacturer changing one product. It's about all the interconnecting companies that form our infrastructure and economy coming together. It's about energy. It's about rethinking the operating system itself. We have a fantastic opportunity to open new perspectives and new horizons. Instead of remaining trapped in the frustrations of the present, with creativity and innovation, we really can rethink and redesign our future.
Hussam,
Okay.
very interesting
Yes.
video. Now we can see your screen.
Yeah, great.
Our current linear economy relies on cheap, easily available resources and fossil.
So I'm gonna go back to my presentation now, and thanks for watching the video. Basically, this presentation puts the perspective of the presentation I want to provide now. And here is the model that we're talking about. Basically, it's biomimicking nature. Circular economy is actually a adaptation of natural processes. So, for example, when consumers are consuming products that came from the natural system, they put down manure and they lay down with the manure seeds, and there's a restoration process happening. Similarly, we take the resources, we think of or redesign new thinking processes to produce new products. Then we also consume in a responsible manner, and this waste is also recycled. So basically, circular economy is actually an adaptation of nature. And if you want to go more practically onto it, our green products that we produce, which are toxin-free and long life recyclable, these reduce environmental footprint. the production itself is cleaner. So we have generation of increased income because we're using fewer resources. We have better services to extend the lifespan of anything, and the collection at the end of the life. So in this we reduce resource dependency, and of course we minimize waste by separation and using of resources. So zooming down into our topic, which is wastewater. How does wastewater fit into this? We start from Lebanon. And as our colleagues just mentioned, we have many treatment plants that are not really operational, although they are on papers are operational. But we have also 65 small treatment plants. They're doing okay, better than the big ones at least. But also, most of these plants, when we talk about small, we talk about medium, they have high capex and opex. We have most not operating properly, as I mentioned, because of lack of funds or lack of know-how, or just corruption, to say it out loud. And they're not efficient. And they're not efficient for many reasons. Some of them are not efficient because the wastewater networks are not complete or missing. Or actually they have industrial wastewater in them, because industrial wastewater can actually impact treatment plants which are not designed for industrial wastewater. And this is another issue. And this is why industrial wastewater is a very interesting gateway now to start thinking about it. One, because Lebanon is not a very industrialized country, and it's a very good chance for us to grab these industries before the whole economy becomes too industrialized and actually make it into a more greener and circular economy based economy. So we're talking about the failure of decentralized conventional system, which are linear, as the video showed you. Very quickly, we have 260 million meter cube of wastewater per year. 6% are connected to a network, 40 are not connected. Out of the 60 connected, they have 60 going to treatment plants downstream, 10 which are functioning, 10% going to a functioning wastewater treatment system. Out of these 10, 30 are actually only primary treatment. So it's not really treatment. It's basically just a preliminary phase of treatment. From the industrial source side, we have 60 million meter cube per year. Unknown statistics, as also my colleagues mentioned. Dominique, he said, like, we don't know about statistics of these, and we need a lot of secondary studies. So basically, we have some of them connected to network, and some of them are just directly disposing into the environment. And these connected to the network actually impact the wastewater treatment plants, which we have built. They make them less efficient. And the one going to the environment have huge environmental impacts, as we know. Just very quickly, treatment plants take in rainwater, domestic wastewater, and sometimes industrial wastewater, as we saw. In Lebanon, we have solid waste that are generated from these treatment plants, sludge basically, and other waste that go into landfills. We don't have incineration, so it doesn't go into energy production, and we're not using them for agriculture officially. Of course, unofficially, many things are happening. Most of the unofficial work is actually dumping this waste sludge into the environment directly also. And from these treatment processes, we also have effluents that are going into the sea or the river systems, or going to irrigation, but not really, not yet, because we don't have any legal framework for that. Now, with the linear processes, I just want to focus on this kind of linearity, because physical, biological, chemical, these are the steps that usually are taken, usually from cheaper to more expensive, if you want to just talk at large. So we have raw wastewater going in, preliminary treatment, then we have clarifier and primary treatment, which is biological. In the secondary systems also we have biological treatment that is sometimes aerobic or anaerobic. And from all of this, we can see on the left side how much waste is actually produced throughout this process. We have sludge from the preliminary residuals and the primary treatment. We have sludge coming from the secondary treatment. And of course, in the end, we have water that is, if it is treated well, it's going to the environment. If not, it's actually also a waste. So how can we combine this in the water framework and the circular economy? Basically, if you look at this diagram, it shows you how wastewater treatment plants are actually putting back water into the rivers in a very linear fashion. This is why it's linear, because it's just a straight line, rain coming down, going into waste, and sometimes also because of our combined system, we have filtering wastewater treatment plants because of rain or storm water that's intruding, and the capacity of the treatment plant cannot handle it. And these treatment processes, if they are actually doing anything, they're emptying into these systems, the river system. However, in the circular economy, we can see how much more possibilities and potential we have. First, if we look at the treatment plants themselves, we can actually look at smaller systems or biological systems like the constructed wetlands, where we have less, let's say, chemicals and less energy intensity, energy use intensity, and of course, operational cost is much lower than. From these systems, we can actually recover easily nitrogen and phosphorus to fertilize crops. And of course, we can talk about rainwater harvesting, where we can actually also feed back into the environment, whether it was in ponds or irrigation, or to the river systems themselves. From these, we can also put wastewater systems on the rooftops or in the communities as a small scale, or do vertical gardens, etc. So basically, if we have to move from today, we have to move from the wastewater treatment and removal of biogenic compounds to thinking about priorities where we preserve natural resources, where we minimize the water footprint, where we use these processes in the treatment plants themselves. Like, for example, energy production we can use in the treatment plants to save energy. And we're going to see examples in a bit. Disposal of sewage themselves, we can look at the recovery of raw materials, energy production, as I mentioned, disposal. Also, the energy can come from the sewage sludge, and utilization of biogas energy. From there, we can also think of recycling that energy into the system. The surplus energy can also be sold into the network. Basically, when we move on a smaller scale, we can look at either diagram C or D. Here we're talking about domestic wastewater, but also you can think of D as on-site treatment for industrial wastewater. Just to give an example of what you can do in the house in wastewater management, here you have different wastewater coming into a small biodigester, and then an anaerobic buffered reactor where it is also treated anaerobically. And then this water is actually polished with a wetland, and then the water is treated. This water can be reused in the house for washing, can be used for toilets, can be used for irrigation, and the treated sludge can also be used as a fertilizer. And of course, the water in the end can also go to the river, which is now is welcoming this water because it's clean. So going into industrial wastewater, we have to know that industrial wastewater is a bit tricky. One, because it's very polluting. The BOD is 100 times more than domestic wastewater. It's laden with chemical and heavy metal components, and it's dependent on variable production cycles, expensive and complex treatment sometimes, and of course expensive in the sense that if you don't recover any of these resources. Our main industries in Lebanon are, of course, the agro-food, construction materials, cement, chemical products, printing, packaging, furniture, and wood. But actually, all of these are still medium-scale industries. They're not really heavy industries. In the agro-food industry, actually, it has the highest potential because for circular economy, because it has very valuable components. And these almost form 25% of our registered industries in Lebanon. Just to give you a very quick sneak peek, we have this agro-food coming from slaughterhouse. We can use protein hydrolysis in slaughterhouse waste to produce keratin from the hair and collagen from the hide, and amino acids from other supplements or substrates. In the livestock production, we can also produce antioxidants, feed supplements. We're gonna see that in a bit. We can, of course, after the digester itself can produce energy, then produce liquid fertilizer, solid fertilizer, and clean water. So throughout this valorization, this is the main topic actually of today, is actually how to look at these wastes as resources. Throughout all these industries, all the options, we have always the consistent resource of water. And this is why we love water so much, is because it's always there. And the valorization of it is always very valuable. And when you reclaim water throughout these industries, you can use it for potable water, agriculture, for irrigation, industrial washing or reuse in the industry itself, domestic for non-potable, also like swimming pools, toilet flushing, etc., as I mentioned, groundwater recharge for environmental plus, and return to rivers, of course, as an indirect use also, which is environmental component. Now, if we take the example of, I'm going to show you some examples, animal farms, for example. From them, we can take methane gas, which you probably know already, through digesters. This is the anaerobic treatment. Later, through further treatment, we can get organic ammonia and solid fertilizers for soil conditioning. And we can also further treat the water into very clean water, or not treat it, but the slurry can also be used as fertilized water for irrigation. If we look at wastewater treatment as an industry itself, we also have a lot of potential there, because sludge is a very highly biodegradable and important resource for energy. And we have many examples of in countries that are using sludge for energy production. From this sludge, we have thickening, dewatering, conditioning, drying. These are the main processes that happen before we put it in the biodigester that produces methane gas. Of course, there is a bit of treatment, post-treatment, where you have to take off the sulfur, but it's not a big deal. And then this sludge can be used for energy production. And I have actually a great example. And of course, there's chemical stabilization later if you want to use it later for different other uses. A treatment plant in Acton in Netherlands has a capacity of 193,000 meter cube per year. It produces 4 billion kilowatts annually, powering 1,200 homes, and the surplus is sold to the network. And 50% of the phosphate recovery, which is called Sous-Vide, is sold as fertilizer, and is dried and used as carbon. The rest of the sludge, is dried and used as carbon for energy producing facilities. This is all saving around 2,500 tons of CO2 per year. And this is an ideal plant, actually. Would advise you to look it up if you're interested. Of course, in Lebanon, one of the biggest industries we have is olive wastewater. We're not going to go through the whole processes of olive extraction, olive oil extraction. You probably can know it later. The wastes can be used, the olive leaves and wood can be used for animal feeding or composting. Other byproducts have olive mill wastewater. We're going to show you very quickly what kind of important pharmaceutical products we can produce from there. Olive cake, which can be used also as energy for briquette making. And other byproducts like olive stone can also be reused. So you can see that in one industry, how much potential use we have, particularly for the water that comes out from this system. We can also get very high value products, which are in the, let's say, medical and pharmaceutical industries and the food industry, like biophenols, which are excellent, have excellent biological antioxidant properties used in medicines and others. Mannitol, which is used in pharmacy as stabilizer for other treatments. Low-calorie sweeteners also. Pectins and oligosaccharides, they can be probiotic and dietary supplements. And other products, for example, can be used for pharmaceutical industry. All of this can be found in the olive wastewater production. And we virtually have none of that. Why is it not going? It's not moving. Okay. The other one I would like to show is the winery. Wineries we have also in Lebanon, and the main byproducts that come from winery are grape stems, pomace coming from skin, seeds, and pulp, and yeast, which can be used for sludge containing yeast, the sludge containing yeast residues and other particles. The treatment and recovery products can be used for animal feed if we talk about the stems, when we mix it with the leaves. And the pomace can be solvent, through solvent extraction, we can use it for dietary supplements. Pomace, aerobic biodegradation can turn into biocompost, and pomace can be used for biogas. We also have the leaves can be undergone into different filtration processes and produce biophenols from that. Slaughterhouse waste, for example, can also be a very interesting entry point. We have different products from the whole processes. Main ones are manure and other fertilizers, disinfected effluent for wastewater use, and biogas as an energy source. I'm just showing you this so you can also look it up later. Whey is a very interesting, actually, also industry we have. Actually, that many of these small industries of whey, cheese production, do not have enough space or capacity to install treatment plants. And this we have already screened about 30 in the BK, and we have analyzed their whey components, and they have a good potential for this project that we are actually developing. Just quickly on whey, most of the lactose in the milk remains in the whey, including 20% or like 15 to 20% of the milk protein. Generally discarded and discharged into wastewater ways, which are has a very polluting effect. It has like almost about 30,000 BOD. But there are high value products that can be done through complex industries. These can be used in sport nutrition, bakery, confectionery products, infant nutrition, and cosmetics. Basically, lower value products can also be done through simpler industry, and this is where you guys can come in. You can think of animal feed, which we are actually doing now, or even do a small centralized biogas from different industries. So whey can, the project that we're going on with is, I'm gonna talk about it in a bit, but basically you can mix whey with animal feed to feed into cows, or keep it, or mix it like dry whey after drying it with the calf milk. Other startups, just to give you an example, Kibos 3.0 is a synthetic biology company in Costa Rica. They have done a solution for whey with fertilizer bacteria to convert it into biofuel. Gram costing ingredients also converted whey into biofuel to power of 34% of the production process. We're doing also an innovative, let's say, project that's developing into collection. Let's say the innovation is more is in the model of management of the whey, and its collection and distribution into animal feed, or converting it into animal feed through direct application. So basically, from the dairy producers, we collect it, we do quality control on it, and we directly distribute it on cow farms on the same day. And this can be turned into mixed with TMR for feed or corn silage. And of course, we have also the okay from the Ministry of Environment.
Hussam?
Yes, I'm done actually.
Okay.
Yeah, I have to wrap up, right?
Yes, please.
So just guys, think of new business models, think of new skills that you have to implement in this, and keep the idea of reducing carbon water footprint. Lebanon needs innovative entrepreneurs like you to adapt technology to Lebanese reality, create new markets, drive circular economy, break barriers of monopolies, and create new jobs. So thank you.
Thank you so much, Hussam. Thank you. I'll ask for the people that has any questions for Hussam, please post them on Slido. We will share them offline. So I'll share it with you now, Hussam, and you can answer them in the discussion box because we are limited in time, so I cannot do it live. Okay, yeah. I'll share it with you now. So, okay, you need to stop sharing the screen, please. Thank you.
Okay. I'm trying to stop.
Perfect then. Yes, you stopped your screen, so it's fine. So, okay, now we will start the last session of this webinar. So in the first session, we welcome Dominique Salameh and Khoder Eid. They shared their knowledge in the field of waste management. In the second session, we focused mainly on water and wastewater management with Hussam Hawwa and Jules Hatem. Now we will start the last session of this webinar, and we will be focusing on energy with two guest speakers, Jessica Abed and Jules Hatem. So, excuse me, Jaya Disciples. So we will start first with our expert in energy, Jessica Abed. Jessica is an independent energy policy consultant. She's also an academy associate at Chatham House and served as a senior advisor for a London-based company consultancy firm. She has been awarded the US State Department's Tech Woman and the UK Foreign and the Commonwealth Office's International Leaders Fellowship. She has been recognized as outstanding alumni by the US State Department Bureau of Cultural Affairs, Top 10 Tech Woman in MENA by the International Business Times, and was featured in Forbes Middle East. So welcome, Jessica. Jessica will be talking about minding the gap, Cleantech in economics activities. Jessica, I think now you can start your presentation, so feel free to share your screen.
Yeah, thank you for having me. It's my pleasure being here. Yes, so I'll start directly with the presentation. Let me share screen. Okay, so I'll be speaking, as you mentioned, and minding the gap, how renewable energy can actually improve economic activities. So as everyone is aware, I suppose that Lebanon has recently defaulted on its debt payments. We have a debt to GDP ratio that has surpassed 150%. So we're in a big trouble. And we get to the power sector. The power sector is accountable for 43% of Lebanon's public debt, which is equivalent to $40 billion if we're accounting for the period between 1992 and 2019. In the past decade, this was on average $1.6 billion per year, depending, of course, on oil price volatility. We have an available generation capacity of around 2,000 megawatt. However, the peak electricity demand is 3,600 megawatt. The technical and non-technical losses are around 36 to 40%. And I'm mentioning all of that because the average ADL electricity tariff, which is subsidized, is around 9.5 cents per kilowatt hour. This is considered high even for a subsidized electricity. And because of that, we have the high generation cost. So the consumer is paying around 9.5 cents per kilowatt hour. However, the generation cost is around 16 cents per kilowatt hour. And that's due to the inefficient power plant and aging power plants that Lebanon has, but also to the, Lebanon uses some of the most expensive and also pollutant fuels, which are heavy fuel oil and diesel oil. But also when we account for all the losses, technical and non-technical losses, and non-technical losses include non-collection of revenues, non-billing, and illegal connections, the AGL cost is actually 28 cents per kilowatt hour. And on the other hand, because the electricity utility cannot meet all the demand, and we don't have 24/7 electricity, and we rely on diesel generators, the diesel generator tariff is 30 cents per kilowatt hour. So that's on average the annual transfers to EDL depending on oil prices. So we noticed that in the year 2012, it was around 2.3. The deficit of EDL was around $2.3 billion. Then back then the oil price was around $111 per oil barrel. Why this is very important for the economy? As we've said, the electricity sector has contributed to 43% of the public debt. We have an outflow of foreign currency reserves for the fuel imports because Lebanon imports around 91%, 91.9% actually, of fuel for the energy sector. And a large share of that, of course, is also for electricity, as we only have installed renewable energy capacity of 7%, and that also includes hydropower. We have a value of lost load because that electricity that we're not actually generating has a value, and we call it the lost load. And there's a very high cost on businesses. They have high operating costs, low competitiveness, whether we're comparing to the regional or international levels, and we also have low exports. So the productive sectors in Lebanon contribute around 16% to the GDP, but they employ 26% of the labor force. Of course, employment now is very important because we have a very high unemployment ratio. And if we look at the trends in the Lebanese economy, even when the GDP was increasing, unemployment rate wasn't decreasing. So we have an economy that doesn't create jobs. The employment opportunities are very important. The industrial sector is around 10% of the GDP. Agricultural sector is 3 to 4%, but it's 8% of the rural GDP and employs a high share of the rural population. The hospitality sector is 3% of the GDP. If you look into the McKinsey report, they've asked industrial players, they've had some survey, and in the top issues identified by industrial players, 37% have complained from the intermittency of the supply of energy, and 11% of the high cost of electricity. We can also see that in the doing business. In doing business reports, we see that Lebanon ranks 143 out of 190 economies. So we're doing terribly. The doing business rank is actually based on 10 indicators. One of them is getting electricity, which puts a score on the ease of getting electricity, the procedures, the time, the cost, reliability, and the transparency of the tariff and everything. So we see in that Lebanon, actually, the score of Lebanon is 62.7. And the lower the score is actually the bad, because the better, Lebanon would get a higher score on doing business. So in Lebanon, and this is for, getting electricity. Lebanon ranks 127 out of the 190 economies. And it's below the regional average of 72. It's even lagging behind Egypt and Jordan and Turkey and all the economies, and all these economies, of course, in the Gulf. And now, even though Jordan is better positioned than Lebanon, I haven't personally surveyed businesses or productive sectors in Lebanon, but I have done that for Jordan. And even though they're better positioned than Lebanon, they do have similar issues. So imagine if it's bad for Jordan, it's going to be worse in Lebanon. So in the agriculture sector, farmers have complained that the electricity cost is a major barrier for investments in agriculture technologies and in all these technologies and innovation that can improve the sector efficiency and productivity. In the tourism sector, we also heard that because the high operation costs also drive, because of the high electricity bills, also weakens their competitivity. And the manufacturing industries as well. So said that because of the high cost of electricity, they have high production costs and reduced competitiveness, which means that for the industries, it either means that they have to drastically cut on their profit margin or also decrease the quality of products, which would also mean that they risk missing the international standards. So imagine if that's for Jordan, in Lebanon is going to be worse. But now you're going to tell me that the government has a plan for 24 electricity. I'm not going to get into the trust issue and whether we actually believe we're going to get electricity or not anytime soon. But let's assume that Lebanon does get electricity according to the government plans. First, we have issues financing that plan, but I'm not going to get into the details of that. The cost of debt is very high, according to the plan, the electricity projects will be implemented through public-private partnership, and the high share of that will going to be a loan that the developers are going to take, and the government is going to purchase electricity. And a key pillar of that plan is going to be that we're going to hike the tariff and reduce the subsidy. We're not looking into the least cost solution. The government is not looking into that, which means that we're still going to end up with expensive and affordable electricity. And then we have the issue of the subsidy elimination. Typically, when governments eliminate subsidies, this is the most common approach. They try to maintain the subsidy for low residential consumers. So in the back of their mind, they're just trying to make sure that there are no social riots and that it happens as smooth as possible. So they maintain it for the poorest population, for small industries, and for agriculture. So subsidy is maintained typically for some period of time for these categories. And we have a significant hike, mostly for the commercial sector and big industries. What that means that the commercial sector and the big industries that are supposed to grow the economy and push the GDP forward are going to be in a worse position with electricity. And then what should we aim for? Definitely lower electricity prices, increased competitiveness and higher imports, improve technology integration and innovation, provide a stimulus for the economy and create jobs, and retention of funds inside Lebanon. And if we look what can actually provide all of these goals, we're going to end up on renewable energy. So renewable energy, especially decentralized renewable energy models, we find that they can be in all these productive activities. They can generate electricity access and affordable electricity, green, affordable, environmentally green solutions. We have also its new business models. It drives job creation. It provides, if you look into examples from different countries, we see that it has actually driven innovation and has provided the stimulus for the economy and created jobs. So this is very important for Lebanon. This is a far-fetched, but I'm just showing the potential in different sectors. So we see that in Hungary, they've actually launched a 1 billion project to renewable energy for agricultural centers that's going to be on the border with Slovakia and Austria. It will cover 30 hectares. It's based on renewable energy, both photovoltaic and biogas, and it will also include a geothermal plant for having cooling, for cooling purposes. If we look into the cost of solar PV in Lebanon, it has significantly dropped in the past few years because the more we have implementation, the more we have companies and competition, and the technological advancements globally, and the market penetration and all of that. We see that in 2011, the cost per 1 kilowatt hour, 1 kilowatt peak, sorry, was $7,000. It has dropped to $1,100 in 2018. This is from Lebanon. This is a farm in Bekaa. It relies on PV. Do I still have time? So in the challenges, we of course face several challenges as well, but there are ways probably, and this is where entrepreneurship and startups can play a role in driving new energy models. We definitely have the financing schemes, but Beritech is also providing some sort of financial support, and if you're applying for the Cleantech fund. We have a legal framework, which is the most problematic issue in Lebanon, that by the Lebanese regulation, only EDL is allowed to generate and sell electricity unless unless it's some sort of developer that has a license, but there's also issues with the regulation and licensing, so we don't have a consistent policy. So we also don't have a power wheeling mechanism which allows users to implement renewable energy technology in a land somewhere and offset the electricity consumption somewhere else. But we have a net metering scheme. Can I start taking questions and I'll get back to that because I lost my voice.
Yes, definitely.
Sorry.
No worries. So just a reminder, everybody that has any questions, please write down your questions. I'll share my screen now. Okay, so just a small reminder, you can go on slido.com. The code is 47485. So the first question we have is to what extent is the lack of development of the electricity sector due to special interest group in the generator business?
Okay, so there are vested interests across the entire value chain. So to be honest, it's not just because of the generators. There are vested interests in the fuel chain, in the development also of all kinds of procurement and power plants and all kinds of, you may hear about all the sectarian division of the project's development in Lebanon. So it's not just the generators, of course not.
Okay, perfect. If you have any questions, we still have around 5 minutes to take the questions before we move on. So we have another one, which is, okay, we have two more. Do you favor centralized or decentralized energy generation in Lebanon?
I'm all for decentralized power generation. First, it's globally, there's a trend into decentralized because of all, it has additional benefits in terms of, especially when we're adding renewable energy, because when we're integrating renewable energy into the grid, we have to also account for balancing the system, flexibilities, frequencies, and all of that. So if you're implementing decentralized, it actually bypasses the cost of doing all these enhancements on the distribution and transmission. And in the case of Lebanon, we have a tough political situation, if I'm gonna say. And so the monopoly doesn't help, and having centralized decision-making process obviously hasn't helped in the past 30 years. So decentralized generation can play a role in bypassing some of the challenges.
Okay, how would wind energy be of value on a decentralized scale?
Okay, so it depends what you're implementing. There's always economies of scale do play a role in when you're implementing utility scale. So when you're implementing renewable energy, it could be a mix of both utility farms, but also decentralized, especially for productive activities. How it can play a role so on the economy of it, in all renewable energy, you have to do the proper siting and make sure that first you have good wind potential and wind velocity. Sorry, I'm having voice issues. And that's especially important in wind when you have to actually do the appropriate wind measurements before implementing any kind of wind project, whether it's decentralized, a small scale, or a big scale utility. Can you send me an email? I'll send you the PowerPoint presentations, but your name now appears as anonymous, so I don't know who you are.
Okay, so we have another. Jessica, do you want me to wait for a couple of minutes before if you want to drink some water, or you're fine?
No, if you to just let me drink and I read the questions.
Yes, yes, take your time.
Yeah, checking the entire. So let's just actually make a difference. Yes, I think you mean the governance structure. I think that's very important. If we look into the solutions provided for the power sector in the past 30 years, there are so many different technical solutions. So the problem is not technical, we all know that. It's not rocket science. We're not trying to invent anything. So the governance structure is very important, the entire governance of the sector, and that's been for so long dismissed. We look into the technical, how you're going to generate electricity, but also the problem in the sector is not just that. So if we look into so many utilities in the world, especially in the Middle East, they have a large fiscal deficit and they lose a lot of money. Although they do have 24/7 supplies. So it's not about generation, it's also about ensuring that you have a least cost plan and a lot of the kind of regulation of the sector and the structure of the utility and all of that. Is a regulator necessary? I believe it is if it's independent, if it's actually performing. If you're going to design a regulator that by law doesn't do by design doesn't actually perform well and doesn't have the right mandates, then it's better to have a planning department. Where was I in the questions?
So how much the renewable energy is part of the circular economy, especially the battery waste and all components?
Okay, so if you look into the PV panels, so it depends what you're purchasing as well and where you're buying from. And the PV panels, if you're looking into buy from PV manufacturers that are part of PV cycle, they actually these panels would be recycled. There are different schemes for batteries, but I have to mention that not all decentralized generation have to come with batteries, even for the case of Lebanon, where we don't have electricity all the time. It could also be a hybrid solution, especially for industries and those institutes and facilities that have already a generator. So it could be a hybrid solution, solar PV and a diesel generator. So you're reducing the use and the amount of fuel you're actually consuming, but you're also when you have, if it's solar or wind or wherever, when you actually have renewable power generation. I think there was a question before that. I just highlighted that as one of the big potential, but there are so many for the agricultural projects. If you look even into here, we have in the agricultural sector, we do have now more solar pumping coming up. And because half of the irrigation, water irrigation in the agricultural sector in Lebanon still relies on the old manual irrigation. So there's a high potential for technology and also in the entire value chain. If we look at the co-ops, there's a high potential for the cooperatives, for the agri-food industry. And there's a bit, it's a growing, I think, the renewable energy integration, but it's still very, very small. But I do find that there are tremendous opportunities if you look everywhere, whether in Lebanon, in the region and elsewhere. And now, especially now that we're realizing more the importance for the agriculture sector, for example, of food security, now that we face the pandemic and we know that food security is very important. So we need to improve that value chain and localize it, and also rely on more technological advancement and innovation to increase our potential locally. I'm not sure about the windmills in Bekaa because it depends where they are in Bekaa. So because of the two mountains in Bekaa, around Bekaa, the Bekaa Valley, so it might actually create some sort of turbulence for the wind over there. So it might not be ideal, but there's also, Lebanon does have a wind atlas. It was developed by UNDP in the year 2011 and adopted by the Lebanese government. So it's online. I think you can visit it on at cedro-undp.org, and you can find the best locations. Can we invest in that? Yes. The cost of wind and solar in Lebanon has been decreasing. There's biogas I know is still very expensive because we do not have, so as I said before, the more we have market development, the more we have competition, the more we have companies, the more we have projects, the more the cost is going to drop down. So we need more efforts into biogas and other renewable energy technologies. We do have tremendous renewable energy potential, even in geothermal, non-river hydro and all of that, but it needs investment, it needs the right policies, and it needs an entrepreneurship also mindset. I'm not personally specialized into mobility, so I'm not gonna tackle that question. But of course, there is so much potential. I think like when we look at Lebanon, it's like creating everything from scratch, really. We do not have public transportation, we do not have anything. So if we're gonna do it, we might as well just do it the right way, with a futuristic approach, with decarbonization in mind. So as I said before, there are so many places in Lebanon where we do have good wind potential, economically viable, because we do need a wind speed. If we're going to utility scale wind farms, we need a minimum wind speed of 7.5 meter per second for it to be economically viable. Now one of the most optimal places is Akkar, where there is a plan, where there is actually a project, ongoing project now. The government did contract 3 companies to implement a total of 220 megawatt wind farm in Akkar. So that's in process, and the government is going to purchase electricity through a power purchase agreement from that. Did I miss any of that? No.
I think you answered all the questions.
I still wanted to say something before I lost my voice in the presentation.
Definitely, go ahead.
Because so there are so many challenges. We are lagging behind on some policies. Like I said, power wheeling. I know there are efforts for a decentralized renewable energy law to have that soon. We're missing on power wheeling. We need the right policies for that. Peer-to-peer electricity, blockchain, and all of that. But we do have a net metering policy, and the net metering actually entails that a consumer that has renewable energy technology implemented on their facility, when they're not consuming electricity on site, they can actually give back the excess, inject it into the grid, and their EDL, if they apply for net metering, EDL is going to install a bidirectional meter that treats how much they've given in excess to injected into the grid and how much they've taken from the grid, and they'll be billed on the difference. And they can carry credit like a cell phone prepaid agreement. So if you have credit in your favor, you can carry it for another month, for a year. Over a year period. The challenge in that is that sometimes we do have the right policy tools, but we have issues in the implementation. It's taking so long when someone applies for net metering to actually get that meter installed, and it can take a year or 2 or so. But we do have some policies, and what I want to say is that there are challenges, but challenges also can be transformed into opportunities. I think that's it for me.
Okay. Okay, thank you so much, Jessica.
Thank you. But I just want to share my email, because I told someone to drop me an email and send them my, just let me share it for a second. It was on my last slide. Okay, so I think I lost the slide. Okay, so I write it in the chat.
Yes, definitely.
Okay. Thank you so much. I write it here.
Perfect then. Thank you, Jessica, once again for this intervention. Now I would like to welcome Jaya Disciples, the co-founder of Green Power Generation. With more than 15 years of experience in energy efficiency, Jad has performed more than 200 energy audits and implemented more than 50 energy saving projects. His passion for sustainable energy aligned with his strong awareness of the important role that nature and the environment play to sustain health and well-being, and that since a very young age. Jad is currently the head of Amana Energy Saving Solutions in Dubai. Jad, thank you for sharing. Just a small, for joining us. Just a small reminder, if you have any question for Jad, please go on Slido and write down your question. So I leave Jad now to lead on the presentation.
Hello, everyone. Thank you for having me. Let me share my screen. Is it on?
Yes, it is.
Okay. Okay, I would like to first start this presentation with this quote. If people aren't laughing at your ideas, you aren't being creative enough. And if you are really an innovator, or if you have an idea, you have to go and present your idea. And you have to be convinced of this. And if people don't laugh, it means it's really not a good idea. And when I was reading a book called Lead with a Story, I found this quote, and I remembered many instances in my career and life where many people laughed at my ideas. And when you come back and think about them, you will understand that this is what made you reach where you are. And I'll give you an example of this story when I was presenting this idea for a big hotel in Lebanon. So I told them that, okay, I can help you save 30% on your energy bill. So the guy was like, oh, very interesting, but who's the owner of the company? I thought, I am the owner. So he laughed at me. And I looked at him. I told him, you will sign my contract. And actually he did. So keep that in mind. In 2010, I created my own company called Green Power Generation, along with my partner, Salim Abdo. And this company is an energy saving company. So the sole activity of that company is to help clients reduce their energy consumptions. And throughout the years, we gathered a huge list of clients. This is in Lebanon. And the client I was telling about is somewhere over here. Yeah. So I don't know if you want to guess who. So we gathered really big names along the years, but this took like more than 10 years. And then in 2018, we expanded to Dubai, where we acquired a big names like Agility, DHL, BRF, Do, and Amazon, where we helped them reduce more than 50% on the energy bills. And these guys, energy bills, we're talking about around $2 to $3 million per year. Whereas in Lebanon, the scale is smaller, but it's the same concept. So anyway, what is energy efficiency, if I may ask? Is it an interactive session or we just talk and then we have a Q&A?
At the end, we have Q&A.
Okay. I like to give an analogy of energy efficiency as a bucket with holes. So, and if you pour water in that bucket, you will have water, but because you have holes or leaks or wastage, you always waste water or energy. So our job is and task to mend these holes to keep the water inside and make it the most efficient. So what is an energy service company? An energy service company is a company that performs studies to find ECMs, energy conservation measures, which are solutions that lead to energy savings. And we do this on two axes. We do it on buildings that are existing. For example, the building you are now, hospitals or that are existing, or on buildings that are on design phase. So we sit with the designers and make the building optimized from day zero. Today I'm going to focus about energy audit for existing built facilities. I'm going to talk about the process, how to do an energy audit, briefly of course, what are the elements involved in it, and then I give a brief case study, and then leave room for your questions. So as I said, an ESCO, energy service company, is in the middle and is like a bridge between many entities. Firstly with the client, when you sign a contract with a client, but it gets involved with the energy suppliers like ADL or generator suppliers. Suppliers, meaning the part, you have VFDs, fans, chillers, whatever. Contractors, funding and grants. For example, in Lebanon, we have the LCEC and UN grants. So getting energy loans to help the clients get the energy loans. And at a point of time, we got the loan and financed the projects. Of course, we deal with consultancy and engineering firms, with experts. Suppose we have a problem or issue in waste or in water, we consult companies and give us their feedback. So what are the steps involved in any facility? So when we come to the facility, first we have to collect data. We need to understand the facility, how it operates. We do so by taking bills from the clients, installing instruments, electricity meters, water meters, temperature sensors, flow meters, gas meter, diesel, whatever you can do to get information about the facility to understand the operation. And the nice thing about this, when you're working with the industries, you also have to understand the process itself. So you don't only have the utilities, you have to understand the process, how it works, what are the interactions between different equipment, and how you can work on each one to find if it's efficient or not, and then reach the conclusion for the solutions. So after doing the measurement, there's the audit. The energy audit is basically, you go to each element in the facility. For example, the cooling, the HVAC, you check how efficient it is, the temperatures, the flow, the leaving temperature, water temperature, returning water temperatures, the operation time. You put data loggers on it to understand when it's on, when it's off, because you cannot rely on the operators. They will just tell you, okay, yes, it turns on in the morning and later at night we turn it off, but you figure out with your monitoring devices that they were actually on all the time. And you would understand the night load, day load, what's happening during the day. So you get very much information from the monitoring. So in the audit, after doing the data collection, you take the data and put them into an energy simulation software to get a data model, a simulated model, and you're taking the actual energy bills to check and cross-check if your model matches the client's bills. So with that, you will get Sorry, it got hanged. Okay, you will get this pie chart, but it will show you what's the percentage of their bills on each section of the facility. For example, now they have their DEWA bills and generator bills that are on a monthly basis. But if I ask him, how much are you paying on HVAC? He cannot answer this. How much are you paying on the pumps, on the boilers, on the lighting, whatever. So with the energy audit, you will get this pie chart and you understand where the energy is going. After having that, you will go on each section and see what's being installed and how we can provide solutions to produce savings. So after giving the energy audit and showing the client with the solutions and what are the savings, if he agrees, you have to go deep into the design, designing the solution, the detailed engineering design, then doing the installation. After doing the installation, you have to prove to the client that you reach the saving that you talked about. For example, if you tell him if you install the lighting system and it will save you $100,000 per year, you have to prove to him that he actually saved 100,000. And if he saves less, you have to pay him the difference. So if he saves 80,000, you have to pay them 20,000. And it never happened in all of the 16 years because you always put safety margin and you make sure your calculations are correct. So after doing the installation, you have to measure. So the measure is in the beginning and measure at the end to compare before and after. And in order to measure, you have to put sensors on different equipment, the process, the lighting, the chillers, the boilers, and IT equipment through an IoT-based system. So if you see now in energy efficiency and energy audits, lots of fields are available. You have mechanical engineers that will assess HVAC systems. You have electrical engineers to assess the grid and electricity. You have programming and communication engineers to do the programming and networking of the system, installing the IoT devices. And with this IoT platform, what we'll have a trend. We have a trend of a facility, and what's here in green, for example, is the expected consumption. So now the black line is showing values between the expected values. But if, for example, for some reason, for example, over here, the consumption is more than expected, the system will give an alarm. And this is based on machine learning. So you have, after this, you have machine learning involved in energy efficiency. And with the monitoring, you will have a feel of the THG, or if there's any noise in the system. You'll understand the demand in kilowatt, and you understand what's happening during the day, during the night, how's the load going on. So you can do energy management. For example, in Lebanon, you have triple tariffs in the industries. So from 4 till 8 p.m. in the summer, you have a tariff of 21 cents per kilowatt hour, whereas at night it's only 8 cents. So during the peak hours on EDL, you can tell them over here, tell them turn on the generators, because on the generators the cost is 17 cents nowadays. And you will reach a conclusion to have a baseline year, which is actual consumption. So this is in brief the energy audit steps. I will not go through in detail. I was talking with Rami, we can do future sessions where we go in details on each of these steps. But basically, these are what I was talking about. You do the facility examination, then you take an inventory, take what's available or what the client has. You make data collection, you make a baseline year, and you reconcile it with the actual bills. And the end-use consumption estimate is the pie chart I showed you. So what's the percentage of each one? Then you will do a list of energy conservation measures, which are the solutions that leads to energy savings. You will put some financing, how much the solution cost, what's the saving, is it financially feasible or not? And then you do analysis and MNV, measurement and verification, to make sure that after you do the implementation, you reach the saving that you're talking about. Part of the solution that we work with is HVAC. We're talking about chillers, split units, air handling units, fan coil units, or whatever is used to cool a building or cool a process. Boilers. So boilers, we talk about a boiler as a boiler itself with the burner, and we check the efficiency of the boiler, the steam network, the steam traps, the insulation. We've installed more than 3 megawatt of solar hybrid in Lebanon. And as we speak, we are installing a 0.5 megawatt solar hybrid for a wooden bakery. But they stopped us yesterday due to the Corona. So of course, LED lighting, which is now conventional, everybody's switching to LED lighting. So this pie chart, for example, if the client decides to work on the HVAC part, we have to prove to him that after the installation, the saving is 29 or 30%. Now, this is a really interesting and important graph, as I'll explain it to you. Okay, this is the consumption, what you see. Suppose we take year 2019. This is the consumption of the client for year 2019. And here, the client decides to implement one of the projects that will lead to energy savings. So this is his new consumption if he does the energy saving project. Now, what happens usually is when you take the 2019 bills, you will have a specific consumption. For example, now due to, to Corona, due to Corona, his consumption will be much less because there's less production and there's no operation. So the client will come and say, oh no, the saving is because my production decreased, it's not because of your energy saving project. And how to solve this? It's in a really interesting subject called measurement and verification. So what we do before implementing the project, we have to create a formula based on linear regression where we put all the variables that could affect the energy consumption and the energy savings. So for example, it could be the weather, and if it's a factory, the number of units produced. So if the number of units produced, we'll have the new consumption going up or down, depending if it went up or down. And you have also the weather, if the weather change. So you implement at any point in time, you implement the variables in the formula and you get the actual consumption. As I said, the fields involved in energy efficiency are many. We have mechanical engineering, electrical engineering, controls, because you need PLCs and smart energy systems to control the solution, civil, chemical, finance people, because you have to assess the feasibility of the project, statistics, machine learning, smart contracts, and blockchain. Now we're implementing in 6 months, we're gonna do the first smart contract linked to energy efficiency projects. Now I'm gonna talk about a case study we did for Slim Oil, which is the edible oil factory. Just to give you a feel, the energy audit took 7 months to complete because it's a big factory and many systems involved. And after presenting the solutions, we gave them all of these solutions with this process chiller retrofit, means changing the chiller, changing an old one to a new one. Chiller retrofit, air compressors, boilers, steam network, insulation, lighting, olive oil boilers, power plant design, where we changed, we put a new generator room, heat recovery, energy management, and waste management. There's a waste of FFA, free fatty acid, in the process. And the client used to burn it in the boiler, and and affecting the boiler. What we did is we found a manufacturer that uses FFA as a raw material. And he was selling the FFA for $1,000 per ton. So going from burning the fuel, we made him sell the high quality FFA. So now I'm going to give a quick example about heat recovery from the generator. You know, the generator is 40% efficient, meaning if you put 100 liters, only 40 liters are used to produce electricity. And the balance goes to waste. So 60% goes to waste. From this 60%, you have 35% which goes on exhaust and 20% on the coolant, which is the radiator. So what we do is we use this 35% going in the exhaust to produce steam in this factory. So you have the generator and you have the exhaust, and we put like a heat exchanger, and it will produce steam. The steam will be injected in parallel with the actual boiler. So in order to do this, you have to include sensors, heat exchangers, you have to pumps and screens, and you have the PLC, you have to program it. So here comes the role of the process engineer or the control engineer or the computer engineer. So in that case, we had 3 generators of 600, 2 of 600 kVA and 1 of 320, and they were running at 12 hours. So we could produce between 212 and 414 kilogram per hour, which is around $81,000 per year. At that time, the cost of diesel was $700 per ton.
Jal?
نعم.
We have many questions. Do you want to take them?
ما هلا خلص أنا خلصت هون وعم gonna.
يلا, perfect.
يلا. So, for example, I'll give you an example. For this project, the investment amount is 200K. The saving is 81,000. So the payback is 2.46 years. I'm not going to talk about the financing part because it's really complicated for now. So I just wanted to end with this. We cannot solve our problem with the same thinking we used when we created them. So when we needed, for example, for the generators, we need something to produce energy. So we created the generator. But generator has many problems, and it's 40% only efficient. So we need solutions to make it either more efficient or make 100% of the waste. Thank you.
Thank you, Jal. Now I'll share my screen so that you can take.
Should I stop sharing? This is my email if anybody wants to take my email.
Yes, and you can put it also in the discussion box as well. So here we go. We have around 6 questions.
Okay. What's the rate of IoT devices here in Lebanon, and do we have engineers who work on that? The infrastructure is there. For example, for now we have more than 1,000 SIM cards with MTC. So the structure is there, but it's very, very, if you want, limited. For example, here in Dubai, you have a platform to control all your SIM cards and monitor all your SIM cards. So there's an IoT-based software and platform to control and check the consumption and communicate with each of them. And concerning the company, you have products for big companies like ABB and Schneider and among others, but I'm not aware if there are really people working with that. And for example, with Roster and Juke, we installed so far more than 150 points IoT-based points for them.
Okay, what is the source of data shown? Is it internal or available publicly?
Which data?
I cannot help you with that. The person that wrote this question, can you please elaborate on this? So Rami Boujoude, who is the Deputy GM at Bioreactor, excellent presentation. What would be, in your opinion, the main driver to make energy efficiency a main driver policy? Incentives, tax breaks, etc.
Okay, since 2010, 2010, there's a program with LCAC and the UN where they did, first it began as a fund. So funding were there for 40% for an energy efficient project. And then there were so many projects that they removed the funding, but there were subsidies from the BDL where they give you an energy loan for 14 years with 2 to 4 years grace period and repayment for 10 years. And Lebanon actually is really, really mature and advanced in the energy efficiency sector. So compared, for example, Dubai just picked up like the last 2 or 3 years, but Lebanon has also policies about energy efficiency. And there is tax incentives in the solar cells, so PV cells, where there's no customs on PV cells.
Okay, what is the efficiency percentage of such a study and cost for under construction single house? And what are the saving percentage approximately per year?
Okay, for the single house, in order to make, because again, to have a project and make it financially feasible, okay, you have to have decent amount of energy savings. And for the generator, it should be starting with a minimum of 200 kVA to give enough heat to give you good output power to heat water or produce steam.
Okay.
For example, I'll just give you an example. For example, if you want to do it for your house will have a generator of 4 kVA or 10 kVA maximum. So now there are no heat exchangers for that small sizes.
Okay, do you provide the option to keep the hardware, software installed for data collection installed at customer site, or it is just for the audit purpose?
Okay, it's an excellent question. Actually, first we used to sell the hardware and software for the client. And then we found an innovative solution where we lease them the meters instead of putting a big initial investment. So we lease them for the period of the audit. And usually all the clients prefer to keep the meters because of the value they get from the data.
Okay, hi, great work. Thank you for sharing. Which field has the largest energy waste?
Which field, if you mean by the industries, which industry, or mainly it's the industries who have the biggest waste. And in the industries, you have the pulp and paper, you have the cement factories, which are huge energy consumers, and pulp and paper, edible oil factories, for example, sunflower oil and touch oils. So mainly the industries.
Okay. Is the energy simulation software used for your projects developed internally?
It is actually, and there are some in the market available, but they're really generic, and they could give you some idea, but you cannot customize them. So the software we use is internal, but there are many that I can suggest you that you can play with to have an idea.
Perfect. Do you provide maintenance for the EE measures? If yes, what are the components that are mostly known to cause leaks and may reduce the EE again?
Okay. We provide, it's depending on the nature of the project, because if it's an EPC, so if we just, the client is paying us for the project, we implement it and leave, we have to make sure that the savings are reached within the payback. For example, in the heat recovery, the payback was 2.4 years. So I have to stay for 2.5 years to make sure I reach these savings. And in order to do that, I have to take care of the maintenance. I have to make sure the system is working optimally all the time. And also if there are components that mostly cause leaks and may reduce the EE again. Okay, so they are, depending on the energy efficiency measures, for example, in the PV, the renewable energy, there are not so many leaks because everything is static. You have the panels and you have the inverter. In other systems, for example, in the heat recovery, you have to clean on a periodic basis the internal tubes of the heat exchanger, depending on the quality of the diesel. But if you do proper maintenance, you will not have any major parts defects.
And we have one more question. I think you can see it, right?
Do you work on thermal insulation in new buildings, thermal renovation, or only on improving efficiency of existing processes like electricity generation? Of course, we work on a full holistic building from, for example, here in Dubai now we're insulating a whole warehouse, and the insulation I talked about also in the edible oil factory where we insulated the warehouse, the roof, and we insulated the pipes. And we don't only work on electricity, we work on electricity, water, gas, and diesel. I hope I answered all the questions.
Yes, yes, you did. So thank you so much, Jad.
Sure.
And thank you, Jessica, also. I would like to thank all our guest speakers.
I will share my email.
Yes, definitely. You can do it in the discussion window. So a big thank you to all our guest speakers and entrepreneurs. So we had Dominique Salameh, Khoder Eid, Hussam Hawwa, Jules Hatem, and last but not least, Jessica Abed and Jaya Disciples. Thank you once again. And when signing out, you will receive a link for a survey. It would be great if you guys can answer the link so that we can keep on improving. For the people that missed the introduction, just to let you know that the Cleantech Learning Series is organized by Veritech under the Clean Energy Program, funded by the Embassy of the Kingdom of the Netherlands in Lebanon. You can go on veritech.org, check the programs. You will get all the information regarding the Clean Energy Accelerator. So mainly what we do is we support startups and ideas that are working specifically on innovation in the clean tech sector. So we're talking about agriculture, transportation, waste, energy, and water as well. I will, before finishing, I will share with you the video in case you didn't see it. And a small reminder, the deadline to apply for the Clean Energy Accelerator is beginning of June, sorry. So if you think you have an innovative solution in the clean tech sector, I urge you to go and start your application process. We will be having 2 more or maybe 3 webinars, so we will keep you posted. The next one is next Tuesday, so it will be the 21st of April. And now I will share the video.